One sec, I'll put the line back so that you can see the path. Yeah, that should be good enough. Hello, Relaxo Man. It's not perfect just yet. There's one more thing I need to do, but overall it's fine. I need to also check the angles, because in this situation, it doesn't realize it can go straight from here to here. Stop stalking me. Hey, you're stalking me. So as you can see, I can go anywhere I want. The line is annoying because it's not centered. So... it's so nice. I wonder if this could break actually. No, it doesn't seem to break. Oh, I probably moved my mouse below. Because there's a point like right here where it's shorter to go down. Yeah, I'll put it on the right click because I don't want to break my middle mouse button. Yeah, it's a lot, like it's so good. Middle mouse action. Let's copy all of that. And that's gonna go to the right click. Right button. Now I can right click instead, it's gonna be better. Because I was using middle click for that. Yeah, it feels better already with a right click. I'll put a variable to help me hide and show the line. Let's use H. Q keyboard, there's W right there. If keyboard action keys.h, I guess. New keyboard, old keyboard. I'll have a variable called showline equals not showline. Perfect. Boolean showline. Oops. Equals true. So at the start I show the line, and then if I press Q, hide it. Yeah, so let's go back up there. Right here. if show line okay, this should allow me to show and hide. Control C, Control. How did you calculate the cost in the end? I'll show you. Not exactly what I meant to do. Oh, I could hide those squares too. Haha. So as you can see, it knows which region it's traveling into. Did I miss C or was there? Wait, when I'm here? Was that a bug? Whoa. Oh, I have a little bug where it goes the wrong way. Why did I not catch that bug earlier? Whoa. But from that side, it's fine. That's weird. That's also... Okay, this is gonna be show cost line. Boolean show cost line equal false. It's gonna be false by default. Did you screenshot? I don't know what you're talking about. Did you get your object from the screen in Agar? Wait, it's not exploring the wrong side. 1 minute. It went there. It abandoned the idea, so it didn't go up. Yeah, very quiet music. What happens here? Whoops. Does it not discover 3.5? Look, if you have the balls, how do you get the coordinates for them so you can eat? Everything has a Y and X axis. This is a weird, super weird case. But what was the other case that I just had where it didn't go all the way? Yeah, I need to actually rework on my cost function, it's so bad. But why does it stop there? Okay, you're on.
I am a robot.
Alright, thanks for the follow. Hey, relax, old man. Hey, is it the same case here? What? What? So this is a weird edge case. Why does this one work? Wow, it's exploring so much. Okay, I'm starting here. I hate this terminal debug console. Oh, it sucks. Every time there's something getting written, it scrolls all the way down. Okay, I'm at start 4.6, so the current node is 4.6. I end up here at I find 3.6. Perfect, and I also find 5.6. Perfect. Now I'm making 3.6 my current node, which sounds very normal. But this guy doesn't find anything. What? He doesn't find up. Oh. Could it be? This has to be it. Let's do that. I'm guessing I'm like right at the perfect point where there's nothing for whatever reason. Y is at the start. Yeah, so this is fine. 0.5f plus 0.5f. Let's see if this is all it was. No. It did take... Okay, no, never. I just re-click probably. Ugh. 4, 6. Now I find a new. I find 3, 6. Good. And from 3, 6, I find nothing. Oh. Okay, that's actually probably one mistake. I'm not dabbing. I actually know what I'm doing. But it's kind of weird. It's so weird. Okay, let's go check again. Right here. It's like putting your nose in your elbow. Well, yeah. I'm not gonna sneeze on my stuff. Something is making this system not work. It doesn't find those, like it can't go in there for whatever reason. It's able to go on the sides. I wonder if I can replicate this, but for the horizontal axis. Oh. Well, then I don't know what it means. Okay, vertical. This thing here is not returning something. So I'm trying to see if my top X Wi-Fi is inside of A. Okay, look for the internet being. Oh. I see. Okay, music should be a bit softer. I'll be right back. Ah, I just hurt my wrist. Oh. Okay, why is this not doing what I'm supposed to do? Vertical, okay, let's print that, I guess. Whoops. Didn't feel anything. So I end up in here and then boop, I can't go up anymore. Three, 6. Found a new node, 4, 6. 4, 6 is not a new node. Oh, what? 5.5, 7.5. Whoa. Who are you? Okay, my current node is 3.6. Oh, okay, I'm at the 3.6, that's why I didn't understand why I'd found the 4.6. Okay, I'm not coming from 4.6 right now. J'ai senti. That's because it's my wrist, not yours. So this should be 2.5. Why is it 5.5? And this should be like... this should... oh, okay, no, it is supposed to be 5.5. 3. 7.5. No, this is good. So why is it not good? Oh no, it's bad! 5.5. No, it is good. Okay, it's good. Why is it not working then? I'm looking if I'm inside. Okay, what is going on? N. I have a node N. I compute a point that is above N. And I compute a point that is below N, which I just verified are indeed true. Now I'm looping through the node list from all of the vertical area of my node. And I'm asking, is top X inside of that node? So is X bigger or equal to the A secondary start. Yes, that should work. And is it smaller or equal to that plus its size? Yes. Definitely. So on the y-axis, is y bigger than the horizontal secondary start, and is y smaller than the start horizontal? Oh, this has to be the mistake. Why that the system even worked in the first place is beyond me. How did that get through me? How did that get through the testing phase yesterday? Huh. I wonder if this is the real shortest path now. Whoa! It's taking a bad shortcut. Yeah, I need to fix my cost function because this is gonna... Later, this might actually do some errors. So while I get my optimization and it works, poop, the underlying thing is really bad. I need to use another color than gray. Wow. And right now I'm not sure if it's shorter to go through this way, or should it be better to go through this way? Right there, I just went through the right way, but if I'm going this way, it goes this way instead. Like, it's only when it's here, yeah. So my cost function is just bad. Like, even here, going through this way, it's probably longer than going below. Whoa, right there. At what point? It didn't go all the way. How did I reproduce that? Oh. Oh, I had it just now. I really don't know. So weird. Why cannot I not replicate this? Oh, right there. Oh. Okay, maybe it's not a bug. It might be when it's really near the wall and it maybe. Okay. Yeah, it's probably when I'm near. Live Streamer is really easy to use. Okay, so let's use a darker gray for that. Dark gray. What does dark gray look like? Yeah, this. Very, very bad. Yeah, it's so bad. What? It's so bad. As you can see, the Pathfinder works in real space. No, it's a custom made, custom algorithm. It's a novelty, I would assume. You can think of it as like a mix of A star and maybe B mesh. Is it B mesh? Mesh. What's the name again? Mesh. Mesh nav. Nav mesh. Yeah. You can think about it as a mix of like a bit of A star, a bit of nav mesh. But it's a lot more complicated than both together. Okay, you don't know that much about it. Well, the difference is that my thing works in real space, so I get a really nice move path where it doesn't go only at 45-degree angles. It goes at any angles that you want. Okay, now I need to fix my cost function. So overall my pathfinding thing works, but it's not like on the surface it looks good, but underneath it's bad. So I'm gonna need to fix that. Draw horizontal area, draw vertical area. Let's hide that if. Show horizontal if show vertical, and then I'm gonna make one more if. Okay, whatever, that works. Show nodes. I can't type. It's hard because my plate is right below my arm, so I'm having to write with my arm on paper. I'm writing a paper, yeah. I'm writing a paper. I'm also like, I have a lot of like, this is all for the Pathfinder alone, all those like math things. As you can see, I took a lot of notes on how it works and everything. Yeah. There's even a bit more here. And yeah. Yeah. But yeah, I'm writing a paper to describe how it works. In the end, it's block based. It's not. It's not block based. They can be. For my game, the map is like the map is drawn from this array, where tiles can be 0, 2. So for my game, it sort of looks like it's block. Oh, I forgot to create the variables. Show nodes. Boolean. Horizontal equal true. I don't have a demonstration yet, vertical, for other shapes. Show nodes. Okay, good, it works. So yeah, as you can see, it went from this dot all the way to this corner, all the way to the next corner, all the way there, all the way there. For now, oh, I wanna, oh shit, I didn't put a keybind for all my other stuff. Keyboard action once. Keys dot. I can't type. Okay, I'll move my plate now. I don't have a demonstration, but I know it works just because it's like, yeah. Just because by definition the system works for all shapes. Okay. Show node. What level of all shape are we talking about here? Would it support perfectly round circle? Yeah, it would. Or does it need a discrete mesh of that? No, it doesn't need a discrete mesh. It actually doesn't even see the circle, but it works for like, yeah. I can give you a brief description of how it works. So instead of having a grid-based map, here's how you divide your map instead. So you can, like for my thing, I feed it. I have a function that converts my grid back into this system. But here. Okay, so let's say, whoops. Oh, I can rotate, right? How do I rotate back? Ah, this is annoying. Okay. Okay, I hold the two keys. Okay. Well, that's kind of neat. Whatever, it's useless for now. Okay, so let's say there's this map. Let's start with like regular shapes for now, regular squares. So the simple thing is you have to divide your map into, or like your terrain, into horizontal and vertical areas. So you're saying this area is this wide, this area is this wide, this area is this wide, and this big area is this wide. Okay? So this whole section is a certain width. This whole section here is this wide, all the way up to the obstacle. This whole section is this wide. This whole area here is this wide. You do the same thing vertically. So you say this whole area is this long, this long, this long, and also this long. Okay? With this, you get some intersections. Okay? So the intersection of a vertical and horizontal area gives you a node. So the node here says, okay, I'm this area that is defined by the two. Hello, they dial. Welcome back. Is defining this whole area here. This is the intersection. Together here, those two, they say, okay, this whole area here is this. It has a certain width and a certain height. It's the same here. Here there's an intersection. This whole area is this long. This whole area here is this long. This whole area here is this big. Okay? And you can do pathfinding on that from node to node. Oh no, I'm not stuck. It works. I'm just explaining how the system works to Raymarch. Yeah, in my visualization they are shown. Yeah, you're right. But now if you want like a circle, for example. Okay, here's how you define your areas instead. Okay, so you have your circle right here. So you know already that it's the same. There's this area and this area. And now depending on how you want to code this, you could divide this in half and say, okay, there's this area on top and there's the below area. And there's this area and there's this area. These ones would be, they're still vertical areas, horizontal areas, but they define this sort of rounded shape together. So this thing, it knows that you're, like it knows the places where you're able to walk. So it's still an horizontal area, but it defines the shape. Like you can have a triangle, and then you're gonna divide here, you're gonna divide here, so this whole area like here, and then here and here. So so from this, like it needs to be like you can, yeah, like these things, they are aware of themselves. They don't care about anyone else. They just care about themselves. And then here there's gonna be one vertical like this, one vertical area right over, and then right here. So now the intersection, this node, there's a node here, a node here, a node here. So this node right here is the node that tells you, okay, I'm actually not a square, I'm a triangle. But like, this node right here knows itself. So when I'm gonna go from this node to the next node to the next node, I know I cannot walk in here by definition because it's outside of the area. I'm not sure if that makes sense for you, but there's another one here. So yeah, by definition of this area, if you coded that right, you cannot go outside of it. And like outside of this zone is an obstacle. Like it's out, like this zone is only here. And then the other ones are squares. What is the reason? You don't need to. I mean, if you're able to code it so that you only need one area, I don't know, I think it makes more sense to divide this into 4. And then it's easier to handle each part. Because if you chew too much, you might just end up like having too complicated code. Oh, hello TyPy. But yeah, like if you want your code to be complicated, you could just have one horizontal area here, and then when it's time to do this, and then have one also for vertical, and then this section would be this sort of weird around the circle section. It kind of looks weird. Isn't it simpler to just have it divided in half instead? Where there's like the top area and then the bottom area. I don't know, that would look easier to code for me. Just like this. And then this one knows like this sort of arc shape. This one knows its arc shape. Heart. Yeah. No, it doesn't. It's like a bit of an inversion map. It's like a picture. What are we doing? No, you don't need a general rule for any time of concave. Like you can have your object, which is like this area, like this node, and this node in the code is aware of itself. It doesn't care about anything else. It doesn't care about how it plugs into them. Maybe it does though. Anyway, I'll have to think about this more. I'm not writing the paper right now, but I've implemented it for my game. You don't place these yourself. You should be able to make your map, and then like writing an algorithm that is able to figure out, like for example, for my game. Okay. How do I find the horizontal area for my game? Let's use a simple map. So there's gonna be that. So all of this is auto-generated for me. I mean, not like I make the map by hand for now. Like later, I can probably generate automatically some maps. But like for the ones that I make by hand, so I say, okay, this here is an obstacle. This here is an obstacle. This is an obstacle. This is an obstacle. Obstacle. Perfect. Perhaps this is an obstacle. Okay. So just looking at it right now, okay, we can see that there's one horizontal here, one horizontal. I'll remove all that afterwards, but there's one big horizontal here and one here. So essentially what your code is gonna do to generate the thing is that it's gonna start at square one. Okay, it says, okay, is this something? Is this what type of tile is this? Should I? So it notices it's an obstacle, so it ignores this one. Goes to the next, and it says, okay, this one can. So I create a new object. I create a new list, and I add this vertical sort of object to the list. So this would be 1. So I add it here. Same. So now I find an object. The object is done. Next. Okay, I find this one. Add it. 2 things. So this is 2, and then it sees that it keeps going. So this is not my best explanation, but you merge those together just because there's no obstacle in between. So this becomes like one big 2. So this is 2. Now you have your, you do the same, add this one, then plus, 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 and this defines your horizontal big area, which is horizontal 3. So you add your 3 to the list. And also every time you add 1, like you're at the end of the row, you need to make sure, you need to check if 3 is exactly the same as 2. In this case it's not. And then here you have 4, it does the same thing. Yeah, it's like you're pretty much meshing. You're going one by one and then merging stuff together. So So you only need to do this once, the first time you load your map. Or you could even save this data with your map if you don't want your game to have to calculate that every time. For my game, it's always gonna... Currently, it's always calculating it. It's not saving anything. And then it does the same thing. So now it does that. Add. Okay, we're at the end of the line. Choop, add 5. Boom, boom. So now 5 is added to the list, and then you do the same thing. Chook. So now you have 6. You reach the end of the line, and then you backtrack. You say, okay, is 6 the same as 5? Sorry, my mic is doing some weird glitches noise. Yeah, it's essentially merging the boxes together. This is easy because it's just a grid square. For other shapes, it would be... The algorithm would be pretty much the same, but with slight differences. What is this? One sec. I hear some glitching. Okay, maybe it's fixed, I'm not sure. Yeah, so now you're done with 6. You check, you backtrack, you look, is it the same as 5? Yes. Okay, well, it turns out that 5 was actually big. Anyway, that's the general idea. I simplified the explanation a bit, because then after that you need to do the same loop again, but now for vertical. So then you go there, you get your vertical stuff, vertical, and then everything. I do a similar algorithm for my tile-based game where I want to optimize the tile collision. Interesting. But yeah, that's the... So going back to the triangle case. One sec, I need to make sense of the question. It doesn't influence the pathline. Okay, so going back to the triangle case, the geometry of that triangle slope area is critical for the pathfinding. Not really. Like this area knows its size itself, kind of. So it knows that you're able to walk here. It knows you're able to walk here. It knows that you're able to walk here. It doesn't know if you're able to walk here because you're outside of there. So essentially it's going to tell you, no, you can't be there. From my perspective, everything else is outside. I know that I'm safe. Likewise, that guy here, he says, you can walk anywhere in here. I know that you're safe if you're inside of here. But the thing is that, unlike NavMesh, you also have the whole area. So what links those two together is this horizontal area, along with, and then here there's another square. I mean, it's a whole region, and this is obviously like normally completely perfectly accurately on this wall, but for the drawing purposes I don't. But yeah, you know that you're able to walk anywhere here. I don't define where you are in this. My Pathfinder, to get real space, it never really knows where you are as you're walking through this. So a valid path would be this. Like if you do this, it knows that you're in a valid path because yeah, it's a combination of small nav meshes that are connected via neighbor network. Yeah, pretty much. That sounds accurate. So you know this path is fine because this guy says, okay, well that guy is never like those parts are fine. Those parts are fine. Like that guy says you're fine when you're here, and this guy says you're fine when you're here, and this guy says you're fine when you're here, and this guy says okay, you're fine when you're here. Wherever you just walked by, I don't really know, but I know you were inside of me. It's not really trying to find the shortest path, but because of the way the system works, it does find the shortest path. But the system itself, like this sort of map representation, it doesn't like this is not the Pathfinder. This is some way to divide the map where I know that if I'm inside of a region, I'm on the map, and if I'm ever somewhere that there's no region, I'm out of the map. So there's no region that knows about this black hole, this empty space, because none of them overlap over it. So it's by definition impossible for you to ever walk over this triangle. Likewise, like this whole map is divided inside of regions. I don't care how you code your circle and those areas around the circle, but if they're coded well, by definition, if you're walking in those areas, by definition you can never be walking over the circle, because those guys are gonna tell you, if they're coded correctly, he's not supposed to be here, because I don't know about this space. This is like outside of me. So if you're always walking inside your areas, you 100% always know that you're not over some obstacles. You're not over like this rock, because this rock is not part of any of those areas. And those areas are defined by the intersection of your horizontal area and your vertical area. That's all they are. They're not anything else. So this thing here, this horizontal area, knows about the geometry of itself around the circle. Likewise, this horizontal area knows about its geometry, which is like this. Yeah. I mean, I make it sound really simple. It's a bit more complicated than it actually is, like when you're at the coding part. But the theoretical of this, like, I mean, you can see right away that it works. And that's why right now my theoretical Pathfinder, like that thing I coded, the current version is not perfect. The path it generates is perfect, but the underlying code, like as you can see, I can walk anywhere here, unless I click outside obviously, but and right now I allow it to be like right on like those edges or like right on the corners. Later I'll probably get this fixed. But as you can see, I can go anywhere here. Let's even hide that, like I can go anywhere. Unless it's outside, I can't go outside, but I can go anywhere here. Okay. So this finds me some real space pathfinding. Which is almost perfect. There's a couple of mistakes currently. I mean, there's one big mistake where if I'm here and I want to go there, I need to check the angle that I'm forming with my obstacle, so that if it's too wide, like for example over 180 degree, then this thing can also be discarded. But the current ugly thing is if you know A star, I thanks TypeI. if you know A star, you go from square to square, computing how much you paid for the travel cost, and then you also have, like, for example, Manhattan, which is the like, you also have some algorithms, not algorithms, like a way to compute your future cost. Consider this case, okay. Oh, that's an interesting case. Oh, it's really nice how you drew over my own drawing. Let's show that. One sec, I'll close my door. Someone's doing the vacuum. So, okay. So what I don't understand is how does it achieve the shortest path with that limited knowledge of the content of the areas? Consider this case, which is shown on screen right now. How does it know the blue path is the right one compared to the upper path with the circle arc? How does it know? Well, just like with A star. Well, yeah, it's pretty much like this part of the Pathfinder is very similar to A star. The way you compute the cost is very different from everything else, though. And currently, the way that I'm doing it is wrong. My new way is better. Okay, this is right there. I kind of want to use that, so you did that with a rounded shape. Okay, sure, I'll redraw that. Okay, I don't want to draw like vertically. I want to make this fatter, sort of. Okay. So how do we know that? Let's go check. Poo poo. Well, I'll explain you with my last version, which is flawed, but whatever. So now you have this in the center, and you have this blue thing. Oh, by the way, your code is wrong already. And this is like a rounded. Okay. So obviously you start by this, where you divide your shapes. Here you would divide this here and here. Thanks for the follow, Halo 314. Welcome to the stream. Here you have your horizontal space, and then you have another one here that defines that. Yeah, they just describe distance. Your code is wrong because you had not included this area. Oh, actually, you didn't include any area. Okay, my bad. Your code is your thing is fine. I misread this as an intersection right there. Yeah. So. Okay, and then likewise we have this right here. Oops. We have one like right here. I'll make this a bit longer. There's one right there, which is kind of hard to draw. Right there, and right there. Yeah, just describing the geometry I noticed afterwards. Okay, so now I have this whole thing, which it's like a part of a bunch of little things. I'll use a different color. Blue is probably fine. This might take longer than I want to. This like ends right there for... Okay, there's this one right there. Whoops, too far. I'm drawing this whole thing. I'm gonna do a straight line for now, but let's just make it look a bit good at least. So I'm just defining the different regions so that it's easier to pathfind on that afterwards. Okay, so now we have this whole area. So obviously this gets ignored because there's nothing that goes over this big obstacle. Okay, let's not think about the code so much, and let's try to think about how do you go about finding the shortest path from your, I'm assuming is A to B. Okay, so we're gonna start here. We want to go all the way here. Okay, let's just put the dot here because my drawing is a bit stretched on this side, but okay. So obviously the shortest path, we can see it right away as humans. It's like this all the way to the corner, or if you want to go up, it's like pretty much this, and then you follow the shape, and then you go there. Okay. So how do you find that with those regions? So here's how my current version that should work but doesn't work because of a couple of reasons. Here's how it does it. You start your thing here, okay, and then you do like A star. You have this thing, you add it to your closed list. Actually, let's not even talk about that, but and then you discover this big square and you discover this big square. So if you go from here to there, you compute the two corners. If you go to the next one, you do the same thing, compute those corners. If you go to the next one, like you know that these guys see this point, because this point is actually inside of this whole horizontal area. Hey, thanks for the follow, Ray Black, Didas Polis. Welcome. Yeah. Let's do the same thing for going down. I don't know if I like this color or whatever. So it's the same thing here. Because one fact that is for sure, the shortest path always uses the corners of your objects. Or if it's an angle, then I guess it would just follow it. It's not really a corner. Whatever. Yeah. So now you explore this next one. Poop, poop. Explore this next one. Poop, poop. Okay. Now you discover this little triangle. So this triangle sees this feature. So essentially you're creating some sort of nodes everywhere that you're like projecting. And so since this guy, like you were in this guy and then you go to this square. So you once again want to calculate the shortest path from whatever, like the path you're currently going is like this. I'll use a better color. So you go from, ah shit, that's not good. Green. Okay. So you started here, you walk down here, now you walk there, and then you decide to walk there. Okay? So your path is going through those circles. Now this guy says, okay, well, I'm gonna look at the nose, I see this guy, and then I compute my own lines, and then this guy says, okay, I can see this dot, I know, because it's sort of touching this horizontal zone, so whatever, poop, oops, poop, poop, then you go here, so this guy, perhaps you went through this way, whatever, so that's the shorter one, then you start from here, and then you project, poop, poop, so this guy uses this dot because it's the better dot, like if you were to use this dot, you would compute that it has a longer travel cost than just going through this one. Perfect, and then this guy, like since this is a big horizontal area and this dot is part of this horizontal area, you know that it sees this. Poop. So this is how you find the shortest path for this. I sort of simplified it, I guess I didn't. But I didn't really talk about, yeah, so fast forward to the circle arc. Now, there's this node here. And then it's like pretty much the same as the triangle thing here, except that now it's an arc. So while you could simplify, like during the search, this could be, I'm already thinking about whatever. This could be still as a triangle, but if you were to use this path, your code needs to know that it's actually following. It's not just like two nodes, it's like a bunch of, like you're following this geometry pretty much. So, yeah. So if you're going from A to B, this is the shortest path. Yeah, I guess that could be the right explanation. So every line in the topology there can be custom distances that differ from the Euclidean distance. Oh, what is that link, by the way, by Flive? Oh, that's the music. Is that what happens? I guess it pretty much happens exactly like you just said. Are you trying to extend the algorithm to non-rectangular obstacles? Actually, this was my first version of the algorithm, working with real space. For my use case, I ended up not working with not working like this. But this is the first way I imagined this thing, like back in 2013. Doesn't that yield? No, not really. Doesn't that yield some interesting limitation? No, there's no limitation because whatever is happening here, it doesn't bother those guys. Like those guys are not in contact with this. This guy is not in contact. I mean, this guy is affected by this sort of size where there's like where it starts and where it ends. This guy is not, but like from that guy's perspective, that guy is a square or a rectangle. This guy is not affected by this arc at all. Like the only thing that's affected by the arc is this little triangle, which is not a triangle, by the way. It's just like a sort of arc triangle. Yeah, if you can find a case that breaks it, that would actually be really nice. Obviously, like right now we're using parallel edges. So So there could be, I mean, yeah. I'll let you find a situation that breaks it. Each area is pretty much the negative of the obstacle. Whoops. So wait, so that effectively means that within a single area, you have to always define every distance from any obstacle intersection with the boundaries of that area. Yeah. Like I'll show you. Let's say you have two objects, two obstacles. Let's say like there's a triangle here. And maybe there's a triangle here. Okay. Well, you divide this like this. There's a vertical here. There's a vertical here, and then there's this part, and then this part. I could have used straight lines, whatever. There's one part here. There's a part there. I'll give myself a bit more room to draw. So there's this part here. All the way down, all the way down. So yeah, you pretty much break it up into less complicated components. Like for example, all this gets broken up, and then you get your intersections, and then there's like this sort of geometry right here. This area, there's this area right. I need to use a different color. Like there's one area that is right there, where it's like right like that. It follows the thing all the way there. This is like a triangle right there. Oh, I forgot one. It's hard to believe I forgot that. There's also this guy, which is like my drawings are not that easy to like. I didn't give myself much rooms to draw, but whatever. There's also one big there that goes all the way down. Oh shit! No, it doesn't. Anyway, like you follow the shapes everywhere. So basically the maps can only consist of predefined area tiles that make up the larger shapes. I think that is right. Does that make sense? Essentially what you end up with is like a linked objects, like this horizontal area needs to be aware of all of its children, like all those little nodes. Okay? So this area knows, like it contains a list of all of its nodes. Likewise, this vertical one has a list of all of its nodes. Also, this horizontal guy needs to be aware that it has an intersection with this guy. So this guy needs to be aware of this guy. Likewise, this guy needs to be aware of this guy. And then this guy needs to be aware of all those three guys. And this guy, this long guy. So everything gets linked up together. And then that's easier to search afterwards. But like, it doesn't need to be tiles. Like the tiles themselves are in free space. This thing could be 2 kilometers long for all I care. It doesn't change anything. Here, I'll show you. Oh, I closed it. So if I draw this map, oops. What happens with a single tile? Yeah, that's like the part that is undefined pretty much. But like, let's say you have this big thing that is like a 6 by 6. Well, even though it's 6 by 6, my thing is only 1 by 1. And until I add complexity, this was a 1 by 1. Or like, even if it's super long, it's still 1 by 1. So for now, obviously this is not like free space object, it's still tiles that are square based. So obviously squares are the easiest to work with. How you code this area, like how you code this little like arc area, I don't know. There could be a million ways to do this, to handle this case. Like maybe you have to introduce edges. Maybe you have to introduce an edge object, where now those intersections are based of like they are like their edges are some sort of object, which could be straight lines, it could be angled lines, or they could be arcs. Like maybe that's how you deal with that. Like in my code for the game, those areas are like just rectangles. But maybe if I were to make a game in like super free space with any angles, maybe I would have to rethink about what an intersection is. Because it's easy to find those intersections. So it's not like you get arbitrary maps like meshes and then... Yeah, you could get arbitrary maps. It's just easier to generate this from... like if I get a map like this, which is already like just an array, it's so easy to just loop from right to... from left to right and then top down, and then generate my regions. If you give me though like a bunch of arbitrary objects, then you start to need code to check, okay, which object is where on the map, and then which object is like horizontally, like over, like on the same as this guy. Like where are my objects? So like if you just give me a bunch of objects, then obviously I can work with that, but it's like you need to start thinking about where everything is placed. Like if you give me, okay, I know there's a triangle somewhere, I know there's a square somewhere. It gets unsolvable? No, it's always solvable. no matter what. You get a circle. Where is it? So then you start to look. Okay, the circle is at X, Y. Okay, so then like maybe a way you could do it is like get your representation, then you place the circle somewhere. Maybe I don't know what. There's so many ways to do that, but and then maybe it's here. And then you place your circle, your square. Okay, maybe the square is here, and then you place your thing. And then once you have those square, like whatever memory way or whatever structure you get, peanut mesh. Yeah. Then you would need like an area that defines the peanut's edges somehow. But it works. Like the theoretical thing works. How you solve that though, like, is up to the implementer. It's like the core concept of this thing. Like obviously you can see that it works. And then whatever thing you do, you can see that this works, where you can just travel it following the edge. It doesn't solve anything. Yeah, exactly. It solves everything that I want, and not more, nothing more, nothing less. Like if you look at a thing, like let's say I look at Blender, and then this is 3D space. Okay, let's just simplify it to 2D space. I forget if I'm on art. Okay, perfect. Oops. And then let's go. I create my, so I say there's somewhere there's a plane, there's a square. I don't know where it is. Whoops. And then I know somewhere there's oh yeah. So somewhere there's this square, triangle I mean. Why is it a different material? Oh, it's not. I wonder why I changed the color. So yeah. Circle. So somewhere there's this circle. Which is, I guess, not a real circle, considering it's just like a bunch of vertices. So maybe in the theoretical world, this would be a perfect edged circle. But in the real world, this is actually just a bunch of straight lines. Maybe that's what simplifies your whole thing. Maybe your peanut is actually this. Whoops. Can I make a quick peanut? What does a peanut look like anyway? No, the thing, I mean, you could hand feed it everything, but you can definitely do it with code. That's a peanut. It's like 2 circles pretty much with like whatever. But yeah, like yeah, I'm not sure what I'm trying to show with that. Let's say you get a peanut mesh, so yeah, so it doesn't solve. I guess it is tile based if you want to think about it that way. I mean, it is like those nodes, those well, no matter what happens, if you're using this sort of system, it's going to end up divided that way. Whether you do this by hand or you do it programmatically, where you give it your map or your objects, and it ends up with this sort of structure, where you have horizontal and vertical, and then the intersections are the nodes. No matter what, it has to be the final result. Like this sort of thing, for this map with those two objects, this is the result. So you end up with those nodes where there's a node here, node here, node here, node here. There's a node there, a node there. So no matter what, even if maybe you do that by hand, or if you code something that does that, it's still gonna end up the same. But yeah, you do have to code it. Still making the pick, sure. But you're right that it does get complicated. Like the all like the map description, it can get really super complicated, this whole thing. But it's always gonna be the simplest possible representation usually. There's also a bunch of side effects that I didn't talk about, which are in action here, but... Oh, I actually had drawn something similar like that, yeah. Oh yeah, so last time I didn't actually divide this in two. I made just one big thing. Okay. Okay, so now what to do? I need to fix my cost function. I think there's a memory leak in Visual Studio Code. It's so annoying. Like right now it's fine, but later today it's gonna start to slow down. Ooh, I'll grab some water. I'll be right back. Okay, so the cost. Okay, so yeah. I need to get rid of all of this cost object actually. I think this is all useless. Actually, doesn't it like it is useless by definition? Yeah. Because I made my algorithm so complicated with this cost object. And then the cost object itself has like in a node bundle it has like top right, bottom left. Like this is all useless. How do I do without it though? Like this is too expensive. It costs too much. Literally and figuratively. How can I work with that? I mean, how do I work without that? Okay. Let's go back to the base. Because I have something that works. And I can, like, I mean, it works so well that it's never gonna fail me. Oops, okay. Like, this black line is perfect. The only case in which it's not perfect is like this, where it should just go straight there, and this is just, I need to handle the angle. But that's not an actual bug in the system, it's actually a feature, because you don't know exactly where you were. Like in this case, you want the corner there, you see? In this case, you also want it. This is like all those cases are the exact same. So basically, what I was interested in. The weather is so bad today. It's raining and it's cloudy. I mean, obviously there's clouds when it's raining, but there's like wind and everything. Okay. Is the problem that arises with an algorithm that has to divide the arbitrary structure into pieces you have code for? This is really nice rendering of your thing. What are you using to draw that? Did you make a function? This is like so good. But like, like, what is this? How is this represented in your code? What's this object? Is that like a bunch of vertices everywhere, like in Blender? Or are you coding this programmatically where you know exactly the arc? So where it starts, where it ends, and its arc's radius, I guess. The subdivision. Okay, well, then no, I'm gonna tell you that it doesn't need to be done by a human. Because you want a map that has this thing. Okay, so you want a map that has this thing. Here's how I code this object. So I say, okay, I know that I'm gonna be playing a game where, whoops, not that. This is not the same thing. Where I have this object, which is like an arc that goes outwards, inwards, and then there's this line. Maybe we can say there's maybe you code all your objects as a traveler. It's a sine curve? No, I mean, it's not, like, maybe you're right that it is a sine curve, but it's not. Okay. So this object is actually really easy to handle. Obviously the algorithm is like something I thought about a lot, so obviously this is like simple, but like, actually let's not draw the square just yet, but I'm gonna redraw this. So there's like this line. No, but the object itself, how to code it, is important to be able to divide it afterwards. Okay. Okay, how does your algorithm... Okay, so you know that it's easy to divide. I mean, it's easy to divide because there's like those nodes right there. So I mean, you divide at those like sort of points right there. It's kind of easy. And then if there's another point here, you do the same. You divide at those sort of points. Oops, wrong. And then likewise, this is another point. And then also where this point is, it's kind of normal that you're gonna divide there. Okay, yeah, so you're saying that given, I mean, I guess you just need to know that, like, the cases. Like, you could make an all-powerful algorithm that handles all those cases. So there's like the square, straight lines, arc outwards, arc inwards, and then there's also the angled lines, which like right now this is 45 degree, but it could be anything. But really this is like 4 cases. There could be like you could have an object that has like maybe not that, but like, yeah, but you're right, like by if you just code this algorithm not knowing what it's going to be used for, then you're going to get into cases where it's not going to be able to divide or represent the space correctly. That's true, and you're right with that. So like, for example, if I'm feeding this shape into my game, obviously it's not going to be able to pathfind around it that well. So you pretty much need to know what you're dealing with. Hello Alvaro AS, welcome back. Well, yeah, I kind of misunderstood the question at first, but...
Et même s'il n'est pas mon légionnaire, il sait toujours trouver les mots que j'attends quand je manque d'air. Qu'il est beau mon Julot. Je suis sa chose et il est mien. Et même s'il n'a pas de veine, mon Julot, c'est loin d'être ivoirien.
Exactly why I'm laughing. Ça sent bon le sable chaud. How does your code know that given a set of pieces, this is only an example case, A, B, C, D, how does your code know that in this particular case, it is never allowed to apply C?
Elle est pas mal, Paulette.
So you're using 2 times A,
J'aime bien sa descente de rein.
B, and D, yeah?
Et c'est sous la couette que je l'aime avec mes mains.
Well, it doesn't match the C. I mean, this looks like a C, sure, but it's not C.
Aucun répit.
How does your code know that in this particular case it's never allowed to apply C?
Mais bientôt je partirai avec mes amis.
I mean, you sort of made this look more complicated than it needs to be. Your pieces are not actually A, B, C, D the same way, but it's A. Okay. You have your B, which is this. Outwards. So this is A. Outwards. Inwards. No, but the thing is that you're making a shape that is different by nature than the other shapes. And then D would be the triangle. So like your way of breaking this down is wrong by nature, so it makes not work. But like if those are your tiles, and then you start using them, so like you said, 2 times A. Like I mean, this is I'm assuming we only use that because we're using a grid to define the map. Or you could say like this would be B A C D. So then now it's just the same as before, you just loop through those. So you find the B, and since B is like your thing, you do like your sort of, you start adding the tile, so you know that this is 1. You keep going. So now this would be horizontal. This would be horizontal. This would be horizontal. Then vertical, you end up with breaking B down alone, breaking C down alone, breaking D down alone, and then you have this one right there. So your nodes would be right there. Like that. Well, I just decided to use this because it fits the current problems. So given your shapes that you gave me, it would make sense to make them there. But if you want them to work in free space, then obviously this is not the right way to do it. Then you're gonna need more work. So, for example, you know, like let's say instead your A is very long. Oops. Maybe you have like your B right on top, which might be actually super long thing, which like it's super long thing there. Well, you know to cut here because this is the index, like this is the location of the start of the arc. Likewise, this is the location of the end of the arc. Like you start marking your important locations when you're in free space. Likewise, if you have C that is right there, perhaps it's C like this. Okay, you have like a point here, you have a point here. There's a point here. Maybe there's another A there, another point, and then D. And then in this case, D is right there. So you just have to cut where the points are. Just like that, you cut where the points are. If they don't line up, whoops. Oh, have fun, Ray Black Didas Police. Thanks for stopping by. Yeah, I saved this. There's a playlist. One sec, I'll give you. Of the previous days. But yeah, like there's come a point where it gets complicated, where you just have to project. So if you have this here, and then this dot is not lined up with anything, so now you need to start cutting this shape. I guess that's what you mean. Yeah, sorry, I'm sort of dense right now, I guess. So this would create a new location to separate it. Maybe this is there. Maybe this is cutting there. I can see that maybe this does complicate stuff a bit. then in that case, maybe you do need to create an edge object. So like this is, for example, the positive space with your obstacle, and then so you get a large shape, but like maybe you don't care anymore about the shapes themselves, you just care about the geometry. So maybe like you're, instead of having a code for like the circle, maybe you have a code like just like Blender did. Like your circle is actually not a circle, it's just a bunch of rounded looking vertices, and together they form your geometry. So maybe now your things need to work on those, like instead of, like no matter how complicated the object, and then you just link them, and then this is your sort of object. And then when it comes time to cut down stuff, then you just work with those vertices. So maybe you start to cut at every vertex, I don't know. I was thinking, like actually, I guess I didn't say that before, but like a circle is simple, okay? It's kind of easy to define the edge, like the whole area around the circle with code, because it's just like an arc, so it's an ellipse or whatever you want it to be. Likewise, triangle is, but when you start to introduce shapes that are starting to be weird, where you can just code a simple map function for it, when you start getting some weird code, weird looking shapes, where maybe this area here is like so weird, or where you can't, yeah. Because I'm thinking you're overthinking this. Maybe. But maybe I just don't understand the question, that's also possible.
Il est d'actualité de continuer la lutte contre Jean-Marie Lapute.
Solution facile, Karcher, démagogie, la France crève sous une philosophie médiatique, politique, cynique, cyclique, merdique et pathétique. Zone tampon, la banlieue. Parc à bétail, ferme sa bouche. Parc à bétail.
Ok.
Peu de menaces, peu de violence. Face à l'indifférence. Peu de menaces, peu de violence. Face à l'indifférence.
Jean-Marie Lapute. It's more tile based than you make it sound like. I mean, it ends up being tiles, but the tiles can be any shape, any distances. So while it does end up being a tile, as you say, they aren't. I mean, it, like, yeah, you're right. It's a tile-based system, but like when I'm creating a zone that is horizontal, okay? All that I'm saying is that this might be like 2 kilometers. Maybe there's another zone that is 3 kilometers. And maybe there's a zone that is downwards, which is 3 kilometers. You can take arbitrary objects as input. They will be turned into tiles, as you say. They will be like, it's not really tiles per se, because they tell you a range. They tell you like information. Like the tiles, they describe the objects that they are dividing. So you're right that any, like, all the objects, they get turned into tiles. So it is tile based, I guess. So you claim I can't tile them automatically, but I claim I can, because maybe you're right that I can't. Maybe I'm gonna get into a problem, but maybe no. Actually, I cannot. It can't be wrong, because the only reason you would not be able to is if your code is not engineered in order to solve the problem you're trying to get. Yeah, exactly. If you know the object programmatically, you can tile it, because you know its features, its edges, you know where it curves, like you know how it, like the object works, if you're able to do it programmatically. But like if you're starting to give me like a function where maybe this is how it looks like, and you say, okay, tile this, then maybe you're right, I cannot tile this easily. So now I need to start looking, like actually converting that into an object with actual lines, vertices. So I need to like simplify this infinitely well-defined shape. Like I know exactly what this shape looks like, however zoomed in I am, or however zoomed out I am. But like if you give me like some sort of functions like this, then maybe you're right, I cannot create the tile easily until I convert the points into some usable values. But anything else is like easy to work with. Or if the object is not well defined, so you don't know where it starts or where it ends, then it's probably hard to tile that because you don't know where it is. But then maybe you're not looking to pathfind around it then, so you don't care. Yeah, so it all comes down to lines and slope. Exactly. But like, you can give me the most complicated objects. No, the arc thing was not misleading. It's when you start having weird stuff then, because I can write code. Like if I notice that my thing is gonna be too complicated, then I'm not gonna do that. But if I'm only having some very simple circles, where's my code? Where's my drawing? I mean, so in this case here, it's simple enough that I don't need to start calculating each single point of the circle. Okay? I don't need to start doing that and then cutting my regions around those. This is simple enough that I know the max point, I know the lowest point, I know the center point around the circle, and I know the other one. So it's very easy to start cutting it's very easy to define regions around those features. Okay? So how does my algorithm? Well, how do you know that there's a circle hidden somewhere? Like the code, like if it's not in the code, then how do you know? Like the circle exists somewhere, so somewhere in your code there has to be an arc. There has to be something that defines this shape. Like how do you know this shape that is hidden somewhere on your map that my code doesn't know about? You just need to get the, like, you just need to code what it is that you need. But my algorithm is used to express the relationship between all of this negative space where you can walk over it. So you have all the outside world that you cannot go. You also have all of this world where you cannot go. What I'm saying is my thing defines the space that you can go, in fact. So if you're inside of this, then sure, you can go anywhere there. And then when it's time to pathfind, like those, like a square is easy to pathfind because at the edge of a square is perhaps an obstacle or perhaps just a useless wall. But if you have like this sort of obstacles edge, which is easy to find because this guy here vertically cannot go lower. Like that guy says I cannot go lower than here, while that guy says I can go lower. So those two neighbors together, they can say, oh, there's something that is happening here. I don't know what it is. Actually, I know that it's just not something that I cannot go. So the fact that this guy cannot go lower down and the fact that this guy can together means that they there's something happening below this guy. Likewise, horizontally, there's this guy that has this size, while this guy has, like he says, oh, I cannot go further that. How can you go that far? Well, there's something that I cannot go there, that is on that side of this area. Yeah, exactly. So the algorithm is like a framework. I guess that's a fine way to explain it. Potentially expanded to arbitrary object, but in fact it doesn't handle them. So yeah, exactly. It only handles them if you need them, if you need it to handle them. Otherwise, then it's not handled. So like this is easy on squares. On triangle now, like that guy says, okay, I can only go this far. But this guy says I can sort of go higher, but not always. And there's like this easy line thing where here I can go only this high, while here I can go much higher. So like this thing is specifically coded for the triangle. Because for your case here, like for this specific map, then yes, I need a triangle. I need to handle triangles. Do you understand why it sounds so ridiculous? No, I don't though. Because for me that's not a problem. Because it actually does handle arbitrary side. Like the theoretical explanation handles it. How you handle it is different though. But like if you follow this, like I'm currently writing this scientific paper for how to work with this. Well, it's not really for from the coder. Like you can just write any code. Like the code, like it's obvious what code needs to be coded, I guess. But the thing does work on any sort of shapes. Like it would only be ridiculous if it was not true. The thing is that right now you're trying to think too much, I think. Like you're thinking like with the current system in my game, for example. So it's true that I cannot map any shapes, but that's because I don't want it to map any shape. So I specifically coded my system so that it doesn't handle anything. Now, if you're making a game where you do require any, like some sort of weird shapes, and then, so yeah, if you do throw like your sort of weird shapes at it, then it's gonna handle them, just because from the start it's supposed to handle them. So if it doesn't do that, then it's bad code by nature. Yeah, I can handle that if I choose to handle it, but I don't need to handle it in my game. You have a lot of ideas for games, but zero game development. So you don't know how to code it? That sucks. I'm so tired. Oh, maybe I should go get some coffee. I'll be right back. Did you suck my energy? Yeah, exactly. You're. I probably should have said that, but you're. You need to. Like, there's a difference between the actual algorithm and the implementation. You're only gonna need to code what you need. You don't need to code more. So, how, like, dependent, like, your implementation is all that matters. But just because you don't know how a shape could be cut doesn't mean that it cannot be done. So, like, the algorithm, you can throw it any object and it's gonna cut them if you have the right implementation for it. But no, it's not always done by the human. It can be coded and it's not really hard at all, actually. Yeah, but yeah, this is a wrong idea. Like, it must be done by the human. It's by nature. The statement that it must be done by a human is flawed, because that's not true. No, the algorithm does handle arbitrary reshape. The implementation doesn't. There's a difference. Anyway, I think I've explored this long enough, so I'm gonna have to keep going. Though I think it was a very interesting conversation. That's why I spent so much time with it. Okay. So yeah. No, I understand your point, but your point is wrong. I thought I didn't understand it earlier, but actually I did. Or maybe I still don't understand, I'm not even sure anymore. But I think I understand the point, and I think it just is flawed by nature. Okay, so this guy says I have a temporary cost. And then I can go from here to here. And then this guy says I have a temporary cost. This is not accurate cost. And then all the way up to there. This is a temporary cost. Let's just make it a bit lower. Oops. Perfect. So this is our temporary cost. And then likewise, if I go... Now if I end up here, so from there I go there. Now it notices that there's a corner right there with my code. Perfect. So it uses that there. And then it gets there. But this location of the code... You don't really want to have to backtrack, do you? cost. So this is all temporary cost, while this is permanent cost. Okay. So as you make your chain, or do I just allow myself to backtrack every time? No, I don't.
Puisque le flower power est fané, puisque j'oublierai demain, puisque les cathédrales sont vides, puisque la Star Academy.
And this thing here, it cannot be part of any of those objects. So this guy's cost is actually there. This is the location that I'm calculating.
Cigarette sera sa dernière volonté avant d'être électrocuté. Puisqu'il gémit, puisqu'il se plaint, puisque personne ne veut de lui, puisque je vous salue Marie, puisque la haine et les cris.
Puisque je vous salue Marie, that's funny.
Puisque le foot est GTA, puisque le pinard et la bière, puisque tu finiras sous terre, puisqu'ils ont tiré dans le tas, puisque les
So you want to backtrack all the way up to a permanent cost. As soon as there's a permanent cost. Or do you? Maybe you don't.
que nous croisons les bras, puisque l'on ne saura pas, puisque les
Maybe while you're searching for the path, it doesn't matter if you need to backtrack all the way down to the starting node. Maybe it's fine.
puisque mon iPod est en panne.
Backtrack all the way up to that node. And this is like a big permanent node right there too. Okay. So this thing works. How do I code it now? So this whole part here is what I need to change. So this had to turn at the corner. I think I can remove this safely. Oh, that was interesting. Whoops. Oh. There's like a split second where the thing is not, there's no syntax highlighting. It's funny. Hello, Atuf6143. Welcome to the stream. How are you doing today, by the way? Hey, by the way, guys, this weekend there's gonna be a League of Legends tournament that I'm participating in. Because this weekend there's the mode 1 for all in League of Legends. So since I play Sion, we're gonna be doing a tournament of one-trick ponies. If you want to watch 5 Sions beat up other champions, then it's happening this weekend. I don't know the timings yet, but it's probably gonna be public knowledge very soon. Okay, so I'm doing the normal A start thing where I start at a node and then I explore the next nodes. Boop boop. Okay, so now I have discovered this node. I calculate this cost. How? I need to go backwards in parent child and do my code that is here. Wait, no, it's not here. It's the Atlas Pathfinder, but it's right up there where I can backtrack. Yeah. Hey, what is that? Is that required? Oh yeah, this is useless now. Is this even required either? This one though is required. This one is not. Okay. Nice, nice. Less code is always better code, I guess. Okay, mouse left point. Which I'm creating my things from there. Okay, in other words, everything needs its own path bound. All of those, instead of a... So those node bundles, they need the path bound. And then when there's an important corner, that's when you start calculating the cost. Okay. Path bound is very simple. It's just x, y, and y, x, and y. Okay. So by the way, guys, so my thing works, but it doesn't work perfectly all that. Like, I mean, it's not. My current thing is a cheap way. Like, I'm currently doing this the cheap way, where if we hide this, where the costs they sometimes don't take. Yeah, they're just bad. Like you see, it's going through this path. So obviously I'm able to simplify that. But in the better scenario, I don't need to simplify the path. Like the cost, they need to be better. Because right now I cannot think of a situation where it would break. But there is gonna be one there, like right there. It just went all the way up there. So while oops, let's go all the way down. Huh. Yeah, right. So yeah, the cost is not always computing the cost of the shortest path it can. So that's what I'm fixing. So while my result is fine, this is not good. And it could be a problem later. And also just having bad code, like it's not good because the algorithm underneath is not good. So obviously it's still mostly good, but it's not good enough. Like later on, it could have to pick between two paths. One is shorter, the other one is more. But just because one of them has to go through this sort of weird loop, it ends up costing more. Yeah, this is just bad. So yeah, that's what I'm fixing. Okay, so the current idea is that each node is gonna also have its node, the path boundaries. So, yeah, and a boundary is just saying create a, like there's a corner somewhere. As soon as you you break one of my rules, essentially. So let's just explain that better. Especially for Fly, because I don't think you were here yesterday when I wrote that code. So the first thing I explained to you when I talked about the algorithm is that there's a corner if you change. That was my first explanation. So if you're inside of this horizontal area and you change to a different horizontal area. Oh, you were there yesterday when I talked about this? No, but you might have been there, but I don't think I explained it correctly. So there's a corner if you go from one horizontal area into the next one. And so as soon as you change, there's something here. It's actually not right, this explanation. Well, you might have been there, whatever. So the actual real way of explaining this is this. Actually, so you start A, and you want to go to B. When I'm in this square, this node, okay, I'll draw my nodes. So there's a node here, node here, node here, node here, node here. Okay, so I'm starting in this node, and now I want to go into this node. But like this node has some properties. It has what I now call path bound, so the boundaries of a node. So this guy says my properties are this. You can only go this far. Do you remember when I drew those lines yesterday? Because this is what this is. So it says as long as you're inside of this whole area defined by those bounds, I have no problem. Now when you get in here, you now have those bounds instead. So that guy says as long as you're inside of this, I have no problem. But now that guy says, okay, am I breaking the bounds? Every time you go into a new node, you need to check if you're breaking the bounds of a previous node. So is that guy breaking the bounds of the first node, which was all this thing? No. So we're fine. Yeah, you weren't there, exactly. So, well, I knew you weren't there, but I mean, sometimes people are lurking, so I gave you the benefits of the doubt. So now you get into here, and then the guy says, am I breaking the bounds of my previous nodes? Yesterday I drew it with yellow. So is that guy breaking the bounds of this guy? So this guy's bound were this. So no, you're not breaking. Let's go back again. Am I breaking the bound of this guy? Maybe, I don't care. Maybe you were there, maybe you weren't there, but I'm gonna re-explain it in case. And also for myself, obviously. I mean, I tried to do it to say that it's for you, but it's actually for me too, because... so now this guy says, okay, no, I did not break the bounds of my parents. Now this guy's here. This guy's bounds... this guy is here. So then he says, okay, am I breaking the bounds of this guy? No, because this guy, like, his bounds are defined by those edges and those edges. So you didn't break the bounds of this guy. Now let's go back. Did you break the bounds of this guy? Well, this guy's bounds were there, and I'm here. So yes, I'm breaking the bounds of this guy. The fact that I'm breaking the bounds of someone else means there's an obstacle. Okay, so now I know that the combination of the bounds of this guy, so this guy's bounds are here. Let's do an actual circle or rectangle. And this guy's bounds are here. And the path is currently going that way. So because the path is like there, so with the direction I'm going, the path and the bounds, like the boundaries, I can figure out that there's a corner right there. So this is like an improvement over if I switch to a different horizontal or vertical or area. Instead I use boundaries. Okay, so yes, I broke it, so there's something happening here. Since I found a result, I stopped there. Okay, no, I don't stop there anymore. So essentially the cost of this guy is the cost of moving from the center to this thing that I just computed. And now I keep going. But now I use this dot as the dot to use for the next stuff. So is this dot breaking the bounds of this guy? No. And then eventually you end up with your original node. So the cost of this thing is the sum of all of those important squares. It's no longer based on those guys' cost. It's based on the sum of all of those important nodes. Like important corners or important features, whatever. So when I'm in this guy, now this guy has those sort of bounds right there. Oh, this guy's bounds were actually bigger. They were all of this. So defined by those. Yeah. Anyway. Now this guy here says my bounds are there. So in other words, my bounds are there. So now that guy starts to backtrack. So he says, okay, am I breaking the bounds of this guy? No. This guy? No. This guy? Yes. So this guy also finds the same feature, the same corner. And then he does the same. And then he goes back. So maybe if this guy finds the same thing as this guy, then the rest of the cost can be computed from this guy, which this guy already computed all of those things backwards. I guess I need to save this. So this guy has to save the cost of everything beyond this point separately of everything beyond this point. Yeah. So this guy goes all the way up to there, and then he checks, okay, did my parent already know about this? Yes. Okay, then I'm gonna trust this guy that I'm gonna trust that this guy computed the rest of the way correctly. Yeah, that makes sense. And then I keep going. This guy, am I breaking the bounds of this? No. 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 Yes. Okay, so then I find this feature the same way as everyone else. And then I say, okay, is my parent aware of this? Yes. Okay, then I can compute the rest of the travel cost from this guy's values. Okay, that makes sense. That works too. Yep. And then I keep going. So this guy also finds this. He says, okay, do you know how much it costs the rest of the way? This guy says yes. Okay, so I can trust you. I get my cost. Then I end up here. Is this guy breaking the bounds of this? No. The bounds of this? Yes. Okay. So I'm breaking the bounds of this guy. Together, those two bounds, which this one has this bound. I'll use yellow. So this guy's bound, this guy's bounds. Together, they find this feature. Okay. Which means that there's something there. So this guy gets its cost from there. And then it keeps going. So, yeah, it keeps going. Boop, boop. And then it ends up being here. So this thing violates the bounds of this guy. So once again, this feed, now you find this. And you say, is my parent aware of this thing? Yes. I can trust that guy to have computed the right values. Boop. So I end up with the perfect shortest cost for sure. And then I end up with this guy, which backtracks. Am I breaking this guy? No. Am I breaking this guy? No. Am I breaking this guy? Yes. I find this. So I find this, and then he can, since it's the same as this guy computed, you can trust that the rest of the way costs the same as your parent. So yeah. Okay. I'm not sure if you guys can follow with my thought process, but it's fine since I can follow my own thought process. And this is by a much better way than the other algorithm where I was projecting. Yeah, because my old version, I was computing like some cost object, which like, let's go down. Like for this version, add to new list, I was computing some cost node. And a cost node was so complicated. Like I needed to create a cost node with the X and Y value of the corner. Oh, sorry. And then I also needed to start calculating the best parent, which is a recursive function. So it kind of costs a bunch. Set cost. Best parent. Okay, best parent get... Like this little function gets me the best parent, which is recursive. Get best parent of everything. And then get best parent cost, and then it has to look. Oh, I could have simplified this function, but whatever, it's gonna get removed eventually. Which like is so bad. I mean, it worked. No, it didn't even work. Like, I mean, it worked, but it's just like bad way of working. Like, it's the worst type of working, because it works, so I could live with it forever. But it's not clever enough. It's not as clever as this way of working. So yeah, as soon as I switch to this method, like so much of the cost, like all the places where there's a cost node involved, it gets rid of it. Is cost important? All this goes. All this goes. All this goes. Okay, I'll be right back. Okay. Okay. So the steps to calculate the cost is to backtrack until there's the same node that I'm traveling to. So if there, backtrack all the way until there's a similar node as your parent. That is, until there's a node that your parent is already using. Oh, my mind is so fuzzy. Oh, I'm not able to generate valid thoughts right now. It's weird. Oh, maybe I need to eat. I think that's why. I just realized. I'll make some bread and like peanut butter. That's gonna be fast. I'll be right back.
nigga, dagger, tita, dagger, dina, dagger, tita, dagger, dina, dana, dina, dana, dina, dana, dina, dana, dina, dagger, dina, dagger, tita, dagger, dina, 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 dana, dina, dina, dana, dina, dina, da, da, tita, da, tita, da. Dagger, tita, nugget, dina, dagger, tita, nugget, dina, dagger, tita, nugget, dina, dagger, dina, dagger, dina, dada, na nugget, dina, dada, na nugget, dina, dada, na nugget, dina, dagger, tita, nugget, dina, dagger, tita, nugget, dina, dagger.
Hey, peace, Ohabu. I'm pretty sure you're already gone, but if you're still here, have a good day. The chair is pretty receptive, so it's fine to talk to the chair, I guess. Okay, I made myself some tuna sandwich. It took a while to make because I got into a political debate while in my kitchen. Okay, so each node is going to have some real node cost along with its how do I call this? Proxy. This is like the proxy travel cost. So your cost is from the proxy. So your real cost is your travel cost from the proxy plus the proxy's actual full cost. Yeah. So proxy cost. So I'm gonna create a new object called proxy cost. So every node has a proxy cost, which you compute by going all the way back. Yeah, very nice. Yeah, okay, that works. There's gonna be a proxy cost. Let's go, proxy, create. So many files already. Add, I'm gonna remove a bunch though, very soon. Proxy cost. And yeah, I'm pretty happy with this name. Dun, 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 dun. Dun, 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 dun. Try premium security for the free for 60 days. This is what I don't like about Avast. It's just so aggressive on its advertising. Cool. No. Proxy cost. I've been sitting here so long, my back is hurting a bit. So many hours in front of the computer. It's like a first for me. It's kind of a float, isn't it? Well, in my case, it's not. IX and IY int cost. This is gonna be a double I cost. So the proxy cost is only about the travel, not about the destination. Yep. Not int double travel cost. For now, I don't know if there's anything else required for this to do. Just X, Y, very plain and regular stuff. So I now have something called a proxy cost, which needs to be included in the non-bundle node. So every node by definition needs a proxy cost. So let's just use a proxy cost. So your proxy cost is something. Everything else is useless. Ta-da. I need to eat. I'm happy to be hearing this song. I don't remember hearing this one on stream before, but I was waiting for the day it would happen. It probably has played, but I probably didn't notice it last time. This is the type of song you'd hear in like Saving Private Ryan. Backtrack. Important corner. So Vietnam. So path bounds are able to compute their corner location. Nice. Nice. Whoever wrote that code is a genius. Path bound, yeah. Really good. Oh yeah, very beautiful code too. Almost want to cry, so good this code. Because this code is so nice. I don't know the notes yet. Okay, first of all, what? I'm given a parent node, and I'm given a node. And I'm saying add this node to my open list. If and only if it's not already in the open list. If it is, check, and maybe the new path is better, the new path I took to reach this. Public double simple travel cost and public double cost to n. Let's call it cost to n at this point instead of like potential cost. Cost to destination, let's call it that. Whoever wrote this song is a genius. That's it, that's all I need. A node, a parent, a proxy cost, travel cost, cost to destination. Boom! All of this can be removed later on. To do, remove the below use. Wow, just that is so much nicer to look at. Okay, so I have now this simple travel cost and this cost to destination. First of all, let's compute this thing just like I did above. Call my... oh, no, I don't. Yeah, I do. Right there. Compute this current boundaries. Okay. Oh, I also need the boundaries, don't I? Public path bound node boundaries. I think that's also required, which I guess I put up there. Boom. Current boundaries. So I have this bound, there is this restriction boundary, and I'm asking if it's inside, or in other words, am I violating, violate is app this node inside. Is am I violating bound restrictions? So if I am inside, I am not violating them. If I am, I am. So let's remove this. If I am violating the bounds, then it's important. Okay, so this is a nicer name, I guess, for this function. Um, Hello, Dark Shadow. What's up? Many things. One sec, I'll tell you what's up. I'm kind of pretty happy about Summary. Oh, they used 3. I finally have a really good looking pathfinding algorithm. Oh, I don't think I can compile right now, can I? There's probably some errors. Oh no, there's none, because So as you can see, I can now move from like anywhere that I want. And it's gonna take the shortest path. So as you can see, it goes from my point and then it goes all the way. So this works in real space. I wanted to make it go, but it's kind of obvious that it's gonna go through the top. Yeah, right there, perfect. So as you can see, the pathing is pretty good, except like there's this little edge case that I didn't handle yet, which is gonna get handled very soon, but not quite yet because it doesn't matter. Oh, hello, Zerq. So yeah, the pathfinding is really, really, really nice. I'm interested in learning to code. Any suggestions on where to start? Yes. Well, first of all, obviously, at first you're not gonna have any ideas of what to code. But I think a good start would be learning Python or JavaScript. One sec, I'll show you something. One sec, archives. That guy says retiring. For the last 10 years, my standard advice to someone looking for a programming language to teach beginners has been start with Python, and now I'm changing that recommendation. Python is still a fine language. It lets you focus on problem solving and not the architectural stuff that experienced developers who've forgotten what it's like to an absolute beginner think is important. The language itself melts into the background, so lessons aren't explanations of features and philosophies, but about how to generate musical scales in any key, computing distance around a running track based on the lane you're in, or writing an automated player for poker or Yahtzee. Then one day a student will innocently ask, instead of running the poker simulation from the command line, how can I put it in a window with a button to deal the next hand? This is a tough question in a difficult to explain way. It leads to looking at the various UI tooltips for Python. Turns out that Guido does the same thing every few years, reevaluating if tkinter is the right choice for idle. Because like you want to code, Python is like amazing. You get to write your very nice programs, and it's all very good looking. The problem is if you want to start doing UIs, and it's not always that easy. The supplied IDE for now is tkinter. It is. A week later, another question. How can I write a simple game, one with graphics? Again, time to do some exploration on what's out. Because there's some libraries. I'm assuming you don't know anything about programming. In programming, you have your language, which means that you can write the code into it. Okay, so this is what C# looks like. The language allows you to do stuff like conditions, else if. It allows you to do actions like corner x equals x or corner x equals a bound dot end x. So those are variables, and you do some actions on them. You can do some math like something plus a value. The programming language allows you to do all that. And pretty much no matter the language, you're always going to have this sort of core concept of like what I'm doing here in C#, I can do in any language I want. I could do this in Python, I could do this in anything. You know, a little HTML and CSS, yeah, so that's not really a good start. I mean, it's a good start, but it's not programming. Or, I mean, nowadays in CSS you can do a lot of stuff like animation, but it's still not programming. But it does mean that you sort of know how to write this sort of things, whatever. Anyway, so what allows the language to do a lot of things, like for me to create a game, is that there's a library. For now I'm using Monogame. So Monogame does all the boring stuff where like it allows me to create this sort of window. So I don't need to know how to code a window, Monogame does that. It allows me to draw those sort of squares with colors. I don't need to know what is a square with color and how it gets drawn on the screen. I tell Monogame, draw me this square, and I don't care about how you do it, just do it. So this allows me to create games with graphics. So this library is done in C#. Like sometimes you're gonna have you're gonna say, I want to make code to connect to a website. How do I do that? Well, you don't need to start learning internet protocols, because you can just use a library that already has the protocol coded in, and then all you have to give the library is perhaps the website URL, and then it does the rest for you. So the language has a certain look, how you write it. So C# code looks different than Python code. And then you have the libraries, which allow you to do stuff very easily. So anyway, what this guy is getting at is that with Python you need specific UI libraries to draw your interfaces. A bit like I'm using Monogame with C# to make my game. So I'm not sure I want to read all that, but essentially that guy is saying a good beginner language would be JavaScript, because it allows you to write your code, and you don't need to start looking for your UI libraries or whatever. You can sort of do your interfaces almost right away. I expect some horrified reaction. Okay, so the rise of non-desktop platform complicates matter, and I can sympathize. My goal in learning Erlang was to get away from C and C++ and shift my thinking to a higher level. I proved that I could use Erlang and a purely functional style to work in the domain that everyone is most scared of, games. Thanks for the follow, Cody Allen22. Welcome. I'm not sure if I'm talking too fast, by the way, for you to follow, but so I proved that I could use the games. Then the iPhone came out, and that was that. Erlang wasn't an option. So you can't make iPhone games on Erlang. That's what the guy's saying. It's with all this in mind that my recommended language for teaching beginners is now JavaScript. I know, it's quirky and sometimes outright weird, but overall it's decent and modern enough. More importantly, it's sitting on top of an unprecedented, ubiquitously cross-platform toolkit for layout, topography and rendering. Want to display UI element, images or text? Use HTML directly. Want to do graphics or animation? Use Canvas. I expect some horrified reaction to this change of thinking, at least to the slight degree that one can apply horrified to a choice of programming language. Those reactions should have nothing to do with the shortcomings of JavaScript. They should be because I dismiss so many other languages without considering their features. Those types or syntaxes simply because they aren't natively supported by modern. Yeah. So if you want to learn coding, like I think that guy is smart enough that his suggestion is good. So you can try to learn JavaScript, code JavaScript. Actually, even with all that, I still say you should learn Python. Because most of the time you don't care about a GUI, like how it looks. You only care about what you get from the terminal and the code. So start by learning programming on like Python or JavaScript. Do some little things, like do a program that computes prime numbers. Do a program that allows you to find a secret number. So the computer generates a random number, and you try to get the human to guess it, and then the program tells you, okay, you guessed 5, look higher. Oh, you guessed 10, look lower. 7, oh, you found my number. So those are like really good beginner programming challenges, which you don't need GUIs to try. You don't need a GUI to do it. Yeah. Project Euler yeah, those are also pretty good. I forgot what they were, but I remember, I think, looking at them. Hey, thanks, Cody, Alan. Oh, you know what? I read your when you followed the notification, and I didn't realize it was you that was asking the question. That's kind of funny. If you want to get into the mind of a programmer, check this website out. Read a couple of the articles. Perhaps you're not going to be able to follow anything, but it's all very good reads, because it gets you into this sort of state of mind of a programmer. Like, if you look at this, what do people like? I don't remember what this was, but for example, like, I wrote Flickr as a business simulator in earnest. Okay, this is another article, but I think it was interpreted more as a theoretical piece. When you build something with the eventual goal of releasing it to the world, the key question is, will people like this? And really, you just won't know until you do it. There's nothing like the actions of tens of thousands of independently acting individuals who have no regard for your watertight theories. What Flickr provides is a way to make lots of quick little products, releases, and see if your expectations line up with reality. Is this my primary use of Flickr? No, but the educational opportunity is there, regardless. Click on a photo to go to the Flickr page. The rest of this entry is an annotated list of some photos I've posted to Flickr, with both my conjectures of how they'd be received and what actually happened. In each case, the photo comes first with the commentary following. I'm not sure if I guess I picked the one article that wasn't the best example of what I was trying to get. Accidental innovation. In the mid-1980s, I was writing 8-bit computer games. Looking back, it was the epitome of indie. I came up with the idea, worked out the design, drew the art, wrote the code, made the sound effects, all without any kind of collaboration or outside opinions. Then I'd send the finished game off to a magazine like Analog Computing or Antic, get a check for a few $100s, and show up in print 6 months or a year later. Where I got the ideas for those games is a good question. I was clearly influenced by frequent visits to arcades, but I also didn't just want to rip off designs and write my own version of the games I played there. I remember seeing screenshots of some public domain games that appeared to have puzzle elements, though I never actually played them, so I didn't know for sure. The puzzly aspect may have been entirely in my head. I had a flash of an idea about arranging objects so that no two of the same type could touch. Initially, those objects were oranges, lemons, and limes, which made no sense, and there was still no gameplay mechanic. Somewhere in there, I hit upon the idea of dropping the fruits in a pile and switch the theme to be about cans of radioactive waste that would hit critical mass if the same types were near each other for more than a moment. Here's what I ended up with, designed and implemented in 5 days, start to finish. Uncle Henry's nuclear waste dump. At first glance, this may look like any of the dozens of post-Tetris puzzle games. There's a pit that you drop stuff into, and you move back and forth over the top of it. Stuff piles up at the bottom, and the primary gameplay is in deciding where to drop the next randomly determined item. It's all very familiar, and except that the goal is reversed. Actually, I just read that, but it went all the way from one ear to the next. There's a pit that you drop stuff into, and you move back and forth over the top of it. So you move your thing, stuff piles up at the bottom, and the primary gameplay is in deciding where to drop the next randomly determined item. It's all very familiar, and except that the goal is reversed, to fill the pit instead, preventing it from filling, there's nothing remarkable there. Except that Tetris wasn't released in the United States until '87, and Uncle Henry's Nuclear Waste Dump was published in '86. I didn't even know that what Tetris was until a few years later. Oh. Was Uncle Henry's as good as Tetris? No, not a chance. I missed the obvious idea of guiding each piece as it felt, and instead used the heavy-handed mechanic of releasing the piece before a timer expired. That's the number in the upper right corner, and keeping 3 waste types separated wasn't nearly as addictive as fitting irregular shapes together. Overall, the game wasn't that what it could have been, and yet it's interesting that it's instantly recognizable as having elements of a genre that didn't exist at the time. So close. Like, you see, this is the type of thinking that a programmer has. While looking for the above screenshot, I found that someone wrote a clone in 2006. The part about the game ending when the pile gets too high sounds like the gameplay isn't exactly the same, but the countdown timer for dropping a can is still there. So I'm not sure if you managed to follow that, but like, that guy is talking about the thinking process, sort of, but also he has like some greater ideas of like the way that you create sort of like the game. Yeah, whatever. So like, go through this website, read a couple of things, and then your mind is gonna start to like get rewired into like some sort of problem solving state. Fun vs computer science, evolution of Erlang style, death of a language. Yeah, like all those articles are very interesting. Daily Programmer. Oh, I didn't know about that one. This is actually the article I should have read. This may sound ridiculous, but I'm serious. The goal is to write a spec for what's allowed to be put into a refrigerator. Actually, this is so perfect. So I intentionally picked something that everyone has a lot of experience with. Here's a first attempt. What can you put into a refrigerator? So anything that 1 fits into a refrigerator and 2 is edible. So you're saying I'm making this sort of computer code and it's a fridge. And now I want to know, and now I have a bunch of objects that I want to put into that fridge. Maybe it's not even code, maybe it's in the real world. And I'm writing an algorithm that's going to look at all the objects on the table and try to sort them inside of the refrigerator. Maybe, whatever, we don't care. Number 1 is hard to argue with. If it doesn't fit into the refrigerator, don't put it in there. and the broad stroke of number 2 is sensible. Motorcycles and bags of cements are off the list. What about liquids? Can I pour a gallon of orange juice into the refrigerator? Alright, time for version 2. So obviously, you can drink liquids like orange juice, but you're not gonna pour the orange juice into your refrigerator. It's kind of a bad idea. Whoops. So anything that's edible and fits into a refrigerator. Liquids must be in containers. Hey, what about salt? It fits, it's edible, and isn't liquid. So you're free to pour a container of salt into this fridge. So you have your salt and then you put it into the fridge. You could say that salt is more of a seasoning than a food in an attempt to disallow it, but I'll counter with uncooked rice. This could start a long discussion about what kinds of food actually need refrigeration. Uncooked rice doesn't, but cooked rice does. Could we save energy in the long haul by blocking things that don't need to be kept cool? That word need complicates things. So let's drop this line of thinking for now. Anything that's edible and fits into a refrigerator. Items normally stored in containers must be in containers. How about a penguin? Probably needs some kind of clause restricting living creatures. Maybe the edibility requirement covers this, except leopard, seals, and sea lions eat penguins. No living things across the board is safest way to plug this hole. So can I put a living animal inside of my refrigerator? I can eat the animal. So yeah, what happens with those live animals? Wait, do the bacteria in yogurt count as living? This entire edibility issue is troublesome. What about medicine that needs to be kept cool? Oh no, we've only been thinking about residential uses. A laboratory refrigerator changes everything. Now we've got to consider organs and cultures and chemicals. And is it okay to keep iced coffee in there with them? It also never occurred to me until right now that we can't even talk about any of this until we define exactly what the allowed temperature range of a refrigerator appliance is. In the interest of time, I'll offer this for experts only spec. What can you put in a refrigerator? Anything that fits into a refrigerator. If you're smart enough to understand, you're saying you're gonna use the refrigerator right, the right way if you're like an expert. But when you're thinking, this is all code pretty much. You start thinking about the system, and then you start to notice what breaks your system. You define the refrigerator as something that gets put into if it fits and if you can eat it. And later if it fits and if it's a liquid, it also must be in the container. So this is the way you think about programming when you start doing stuff. I'm not sure if you're still able to follow that, but this is very, very programmer type of thinking, perfectly. like when you're a programmer and you start talking to other people that don't really know programming, this is one of the biggest frustrations I have. Like, people don't understand what I'm talking about a lot of the time in real life. Like, there's a lot of programmers jokes that I find so funny that other people can not even get a glimpse of the humor. Like, the other day I was looking at that other website, Vigil. Like, when I read this, like, I can't even, like, I can read this 20 times, and just this, like, final punchline is like, I always lose my shit. Like, I can't even read it. That's why I'm like trying not to look at it right now, but like, the implication of this thing is like so funny. Like, it's just so good. But people don't understand this sort of humor if you're not into it. Like, if you're not a programmer. But if you are, I'm pretty sure everyone finds this funny. What's that? There's issues? Any idea about punishment main? This is the noblesse of programmer. Dead code, punish code, whatever. Yeah, I mean, the pull request. Someone made a punish a. So yeah. Like, when you understand the implication of this thing, it's really good, but like, if you're not into programming, it's kind of almost impossible to understand the implications. But this is the equivalent of saying, like, I'm creating a TV series with characters, and when if one character has an error, like, for example, one day I say this character is born in 2000, and then later in the story I say this character is born in 1995. Then you say, oh shit, there's an error. So then your script writer, he starts going through your characters. So he removes the character that has an error, and then he starts going again. Okay, remove all the characters that talk to this character, and then you start removing everyone. It's kind of the same idea, I guess. Anyway, enough of that. But yeah, as a programmer, you're like an alien to society. Because the problems you solve are like so specific. The soundtrack is good. This sounds like StarCraft music. Brood War. No, now I need to fix the... I need to include a proxy cost. I need to rewrite my code right now so that the cost is better. Because right now this is the bug. J. The bug is that this gray line is not good. You see? It's like not always taking the shorter way. Like, you see, it went to this node. Yeah. Whoa, right there. You see? Whoa, this is disgusting. Oh, this is so disgusting. So ugly. How can I... Whoa! So yeah, that's what I'm working on right now, getting a write code. I mean, I know exactly the code I need to write, but I'm eating, so that's why I'm like talking about so many random shit. Yeah, exactly. Puke. Like, get the news ready. This code is like reason enough to end this life. I'm kidding, obviously. Oh, I should have put some cheese too. I forgot. I do have some cheese. Not this type, but some really good cheddar cheese. Slasher kills. That was funny. Like the plot twists are just that good. Let's restart. It's a fucking turtle. And then you get to the reason why he's going. Hey, hello H-man. Long time no see. Oh. The guy that's making the sound from the start is that guy, is it? Oh wait, no, it's not. Yeah, they're both making the same sound. Okay, that's enough. I'm not gonna ask. I guess I need to put this in broadcaster language mode now. Okay, I'm gonna answer the question for you. Oh, you're gone? Okay. Well, that's the perfect time to come by and leave, I guess. I'm not gonna assume that it's... I'm gonna assume that you do have a class and you're not just leaving after seeing that. I'm kidding. Okay, so now I'm saying find me first proxy cast. Private proxy cast, get first proxy cast. Who scared the shit out of everyone. So this needs to be recursive, doesn't it? Yep, it does. So given an APOS node A and a parent node, node bundle, oops, B. Okay. I'm not clicking that link. A parent node. Nah, I'm not clicking that. Okay, so if A is breaking the contract of node boundaries of its parent, then it's important. Da, da, da. Check if I break the contract. So if B dot what is the name of the function again? Proxy cost dot boundary node boundaries dot is violating restrictions. Nope. And I give you A. So is A violating those restrictions? If oops. Am I violating that? Oops. Yes or no? Yes. Return. So I give you the AX and cost. Fuck signs. Like this website. That's a funny website. Dun, 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 dun. I didn't know this was in the bot. I did, but I didn't. I forgot who put that there. But hey, maybe I should make the comment. Remember who. Oh, Appasbot, you're so reliable. So get the corner locations. Oh yeah, this is so good. Corner locations. It's like the game where you have to make eye contacts. So Appasbot never breaks eye contact. This can be a float, it's fine. Very fine. The location of this proxy thing is b.node boundaries. Get corner locations. Okay, I give you the path bound A and B. Oh, A does not have a path bound yet. No, he pretty much sold his life. He is very dedicated. Dedicated. Okay, path bound. Boom. Oops, I could have sworn I just put a semi. So the node bounds. I really like this type of sort of ambient sound.
I am a robot.
Thanks for the follow, the One Dutcher Gamer. Welcome to the stream. If I wanted, I could just listen to this. Look at that. This is amazing. I don't know where I put it though. Where did I put that? Okay, there it is. This is something I really like to listen to. I might actually use this for the game. I want some city sounds. Ambience and weather. City far. Whoops. A bunch of ambient sound. So this is rain so far. Yeah, this is so fun to listen to. Rainy mood. Those are shorter. This one is 3 minutes. This could be a nice change of pace instead of music. Alright, put the music very low music with yeah, I kind of like that. Let's do this for now. Can I loop this? I want to loop everything. L'Acuron. Okay, let's try that. Oh yeah, this type of things. And let's put some thunder. Can I open this? Thunder and rain. I want to make this a different one. I don't want this to open together. The music is good now for this. So how do I open the thing from a different... I guess I do this. Yeah. Let's remove all of that. And now let's put the winds. This one is 3 minutes. Let's loop that. And let's add a bit of water from the chute. Water flow. Okay, let's do some sound balance on this. Whoops. I don't hear thunder. That's what I wanted to hear actually. Where's my thunder? I want some massive thunder. Hey, I'm outside now. Live audio mixing with VLC, yeah. This is where it's at. Yeah, this sounds a lot better, doesn't it? With the bit of music in the background, and then you have your... like you can hear the thunder a bit. I could probably mix a bit more thunder. Some sharper thunder a bit. Ah, yeah, the thunder. Ah. With trees being cut down, what is that? Ha ha ha. I guess I use a different thunder than... Oh. Let's go. Now you have all this, the sound mixing together, and you hear the water and everything. It's so chill. Okay, let's keep going now. This changes a lot from the usual Ugh. Like having real sound. I could even put some people talking. Like cafe type of ambience. Sound of Hong Kong. Nah. The sound of Hong Kong is not that good. Oh, we just hit that big one. What is that? Oh, brass metal. Kind of hard to hear because the sound is low. Oh, battle crowd. That's good. Oops, I didn't mean to close that. A sound DJ. Someone should get that as a job. Actually, probably some people already do. The sound, the train is right there. I can see it. So right now I'm like there. I'm sitting right beside the train track, with the rain under a tree, with my little. Where did I get those sound from? It's Sonis.com. I'll give you the link. I'll just check if they're still free. Whoops. So it's all with a license. Sound effect libraries. So these guys are really cool. Once in a while, they release sounds that they're allowed to use. Sound is pretty on Soundify for games of high quality sound, many royalty-free single license from many of the best sound recorded. So they release those sounds for the world for free. So obviously you don't get everything. You only get like a certain package. But it turns out their package is how many gigabytes? This package is 9 gigabytes. Let's go check. This.com. Like this is the type of thing they give you. Hello everyone, hope you are well. This is oops. This is Timothy McHugh here from Sonis. We couldn't make it to the Game Developers Conference this year, but wanted to do something special for the community. In celebration of 2015, we teamed up with many of our suppliers to offer all of the Game Audio GDC attendees and non-attendees a large number of premium sound effects. Check out the following links for more information. Just added torrent link. What the license of these files? Royalty free. Thanks twice. Yeah, these guys are like amazing. This is a great resource, not least for the prototyping and polishing, but not available for long. It's probably anyone get a mirror. I put up a mirror anyway. So like these guys are like amazing. I would still be careful as a person who uploads indie game. I understand your concerns completely, but as the CEO of Sonis, I have been given permission to give all of these files for free. There is nothing to worry about regarding copyright. You certainly mean the best, but there are thieves who put in false claims. It sucks. Huh. Thank you for this amazing bundle. And they did a second bundle later. I'm not sure if I can find it, but they made a second bundle. I don't have it on this computer, but on my other one I do. Okay, so node bundle, and then I calculate this path bound. In other words, node bundle doesn't need oh, I've already removed it. Really good. Oh. Now that this is done, this thing no longer needs nodes. A node, B node. Okay. So this whole code needs to be brought up one step and put in here, I think. So now this is gonna be A, and I'm gonna ask for B. It's lag. So A bound is actually node boundaries now. A node is me. I need to be careful what I do here. Oh, B. Okay, let's undo everything. Okay, so B is no longer there. Okay. So B node is me. Okay, and then X is actually my node boundaries dot X. Okay. And now I don't need this anymore, I just need the A node. Which means that it's gonna be A node dot node boundaries. Okay, just to make sure that this works, to remove that for now. Let's go back up there and use this new code instead. So path bound, get wrecked. No longer required. And now instead I use path memory. But get corner location. And I don't give you this anymore. And I don't give you the boundaries anymore. And also at this point I only want to loop over this. You're a bit tired? Peace. Have a good day. See you tomorrow maybe. So does this crash? What happens here? Okay, good. My line still gets found correctly. So my code is equivalent to what I had before. Yep. All good. Yeah. No, now that I know that this works, get rid of that. This is no longer required. Current boundaries equals backtrack.node. Let's just make sure. Yeah. Oops. Okay. Is this not used anymore? No, it's not used anymore. Okay. And also let's just rerun that again and just to make sure. I can never be safe enough. Nice. Whoops. I clicked outside the screen with right click and crashed it. Why did it crash? Doesn't it crash now? What crashed it actually? Okay, so that's a lot of code that's been simplified. Okay, am I violating anything? If I am, then what? What do I do? So A is guilty of breaking B. I don't want to break everything right away, so I'm gonna incrementally add this variable, which I need to compute now. So the first one, I need to stretch. Okay. It's nice, the weather is starting to get better. I mean, the real weather, not this weather that you guys are hearing. Okay, so proxy, no, proxy cost. First proxy cost equals new proxy cost, boom, which is the starting location, start location, and the cost, which is 0. Perfect. So that guy's saying I have no parent. Right after that, I give you my first proxy cost. Yeah. And then this guy. This node bundle also needs to know the distance between itself. Simple travel cost, cost to destination. Okay, that's good. Hey, by the way, welcome to everyone that's watching the stream right now. It means a lot for everyone that's there. Okay. I'm eating so slowly. Hello? Okay. I don't know when I'm muted, but whatever. So in case you didn't hear that, so I want both the multiplayer and the co-op. It sort of makes sense to have both. And it's not that complicated to have both, I guess. As far as I know. So yeah. I wonder when my mic got muted. Probably it just crashed while I was away. Okay. So get first proxy cost. Oh, never mind. I do need the parent. Because I need to go down. Okay, so if b equals null, do something. Else if I cannot go down to the null one. Hello, Skynet, Skatenet, Skatenet, and thanks for the follow. Where's my pony? Welcome, guys. BC. What kind of game is this? This is the type of game. What are you making? This is what I'm making. Okay, so I'll explain this. The game is a sort of top-down game where you're looking at the ground, and your goal is to go from one area, like one platform, and all the way to the next platform. Not roguelike. Maybe one day I could make something based on that roguelike, but not now. So your goal is to go from one platform into the next one. If you do that, you beat the level. I mean, you beat the level, and once you reach here, you're ready for the next level. So the game is a obstacle course. It's a time-based obstacle course where your goal is to try to cross over through this, and this is obviously a puzzle. So the obstacles are time. Sorry, I'm really bad at explaining for some reason right now. So the obstacles are time-based. So for example, at 1 second, maybe something is gonna explode here. At 2 seconds, maybe something explodes. So you need to sit here, observe the puzzle, and figure out where to be and when. So you can't just run across this. If you do that, you're likely to be hit by an obstacle along your way. So a good puzzle would not allow you to just run through it. Yeah, so you need to figure out where to be and when. So you can't just run in a straight line. In some cases, you're gonna be running all the way to this corner. Perhaps you go back here to avoid whatever obstacle. Maybe there's an explosion here, so you need to go backwards. Then maybe you need to run all the way to this corner. And then once you reach the corner, perhaps you go back here and then wait 2 seconds perhaps, and then run all the way to the end. Maybe that's what the puzzle is. Perhaps you're for this one, you start here, you wait, and then at the right timing you go in. Perhaps you go down here, go back, cross over all the way here. It's live. Hello Kiranga, you made it. Then after that, and I'm still here for like another 2 hours and a half. Perhaps you go down here, go back up, and then run to the end. So maybe that's the puzzle. So like the game is played. It's mono game. You don't like mono game? Why not? So the first phase is you sitting here, observing the pattern and figuring out how to solve the level. And the second part is actually going in there and trying to survive without dying until you reach the other side. Yeah, so that's the core mechanic of the game. Yeah. The controls, they're like, you start somewhere, and then just like in League of Legends or StarCraft or game where there's pathfinding AI, you start somewhere, and then where you click, the game brings you there. Okay, so I can... it's okay for its purpose. I mean, it's great. It allows me to create a game that will work on Windows, Mac, Linux, and then later, if I want, I can even bring my game to iOS or Android. And I don't need an engine. I'm coding everything by hand. Like my pathfinding AI, algorithm, I'm making it by hand. The graphics, I'm doing that by hand. Like everything. So Mono Game is definitely a really good choice for me. Hey, what do you guys think of the sound right now? I put my music very low, and I put some thunder, some rain, and a train. Is that annoying, or do you guys like this more than just plain music? It's kind of an experiment I'm doing right now. Is it a wee bit too loud? You don't know about the train? Yeah, maybe I should just remove it. I could put some other object instead of a train. Like, I don't know. Maybe, or maybe nothing. Industrial warehouse, what is that? You guys hear that? The nails and everything? So you can see the sound right below. So right now it's Lobstana David, Qui nous étions, part 13 instrumental. Oh, I just closed it, that sort of nail thing sound. So yeah, that's basically the game. So I'm gonna be making a story. So where there's gonna be some sort of campaign where you explore this sort of bound world. My current idea is that I'm gonna be doing a sort of afterlife game where you die. What year are you in uni? I'm not anymore in university. I think it still says that under the stream, right? Actually, I did that. So yeah. Okay, this is edited now. I put it in the past tense. Are you working? I guess this is my job for now. So I worked a lot last year and this year to get a bit of money so that I can at least live for a few months just working on this game. So I mean, if I can make a good amount of money on this game, then it's good. If not, then at least I'm not in ruin. Like I'm still not dying. So yeah, this is sort of my job for the next couple of weeks / months until I'm done with this game. So that's why I can do this every day for like 8 hours per day. So eventually I'm gonna want to introduce also a multiplayer mode where you can play with your friends. So everyone starts, for example, at the start, and then if you're in a co-op mode, for example, the first guy that beats the level unlocks it for everyone else. That could be an idea. Or you could also have a competition mode where it's a race, so everyone tries to beat everything until the end before everyone else. That could be also an idea. Also, it could be a competitive mode, but co-op. So a co-op competitive mode where your goal is to beat the level before everyone else, and the first person that unlocks the level gets a point, and then at the end the person that has the most points wins. So that could be an idea, for example. So it's like a mix of competitive and co-op where like the first person that beats the level unlocks it for everyone else, but he also gets a point to show that he's better than everyone else. So that could also be so that's for the multiplayer. So I want some sort of competitiveness to it, and also a co-op mode where you can play together and try your best to beat it. And then also eventually I want to code an endless mode where you can just keep playing forever. So not as much story as the campaign, but yeah, so you can just play forever. And the campaign itself too, I don't want to have a big heavy story. I want something that is there and that sort of makes the game, like it adds in different depths to the game, but it's not necessarily in your way if you just want to play the game. That's my current idea for now. So yeah. C proxy node. Proxy cost. Okay. So if B is null, return the proxy of C. Yeah, peace, Kieran guy. Thanks for stopping by. I saw that the other day you came late, but. Oh, and by the way, I'm recording everything. So, and then everything, like every past stream ends up on YouTube afterwards. So it's possible for people that are not able to watch me live, they can still see the stream. And then they can skip over the long parts where I work for hours on one thing. So if B is null, that's it, you're done. If it's not null, then I want to keep, then I want to return. Alright, I moved this there. So now I get the location get the corner location of that and then return that. Okay, so I guess first proxy cost location. So I give you this. Okay. So now I get the location of this. Perfect. And else I have to return get first proxy cost location. Okay, and I'm gonna give you A. I'm gonna give you B, but I'm also going to give you B.parent. Dun, 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 dun. This is good. I think this is gonna work. So A is not violating B. Then go deeper until A finally does violate this new B. Recursive. Okay, good. Down. So this guy just gives it the parent node twice. Why does that not work now? B and C. Hey, I actually... So I know that my node A is passing through this proxy cost location. I know that for a fact. So now I need to check if my location is the same as my parent. If parent node dot proxy cost that position equals proxy cost location. OMG parent. If it is not the case, then I create a new proxy location. Da 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 da. Da 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 da. Da 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 da. Proxy cost. Okay, proxy cost. It needs the proxy cost location as well, along with the cost. Travel cost. Da 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 da. Okay. Okay, the cost is gonna be computed somehow. This is gonna be from my... Let's make a variable for that. Location. Get node center. This sucks. Dun, 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 dun. Whoa. Careful there. Okay, sorry about that. Because I tried to compile C#. I think you need to do this build. Oh. Like you need to press this F1, and then you can do your build task. But first you need to set it up. Why not community? What do you mean? I do have the C# configure like plugin installed. C# right there. C# for Visual Studio Code. But I am also running a real Visual Studio beside. So there's a part that this Visual Studio Code doesn't do that well. It's to add files. So every time I create a new file, I go for it from the Visual Studio. So I do as usual add. So I'm kind of cheating in a way. So I want to use Visual Studio Code, but I can't. Oh, Visual Studio Community. What is that? I actually never heard of it. Visual Studio Community. What is that? A free, fully featured and extensible idea for creating. I actually never heard of that. Is it like alternative to Visual Studio Code? That's interesting though. Code is a stripped down version of Visual Studio 2000 with emphasis on in just writing the code instead of dealing with debugging, compiling, testing, refactoring, and all the other things that make Visual Studio great again. So I guess I am using Visual Studio Code because it's simpler. The people using Visual Studio Code will probably be those on Mac who will just deal with client-side technology. Okay, well, whatever. So I guess I decided that code was enough for what I'm doing. That guy keeps asking the same question. Anyway, yeah. I didn't know about Visual Studio Community, so that's why I didn't use it. But I think it's nice that I'm using code because it works on Mac and Linux, which is kind of a nice plus. Eight gigabytes, whoa. I mean, there's a lot of things that are annoying with Visual Studio Code. Like, I really hate their console. Like this thing right there. It's so slow. And also, if I select something and I scroll up or down while the program is running, or right there, I just lost everything I selected. So like, I'm scrolling up, trying to copy a bunch of things. Like, I want to copy all of this. Boop, boop. Try to copy, and I want to copy all the way here. Well, it just lost my whole selection. So in order to copy stuff completely, I need to do a couple screens. Like I need to do this, copy, paste. Perfect. Go down. Poop. Copy. Paste somewhere else. Poop. Go down. Copy this. Like it's so tedious. It's so annoying. Like the only way I found to make it better is to zoom all the way out so that I can have a bigger amount of console. Like how dumb is that? It's so annoying. And it's so slow too, compared to regular terminal for debugging. Like the text that gets printed here is so slow to appear. This is shit. Okay. Let's do that. Public location. Get center. Oops. Turn new location. Okay, it's not made to work with C#. Yeah, but that's not even C#, it's just a compile debugger. It's just a console. Like, their console has to be so bad if it's so slow like that. Okay. Left. It's top Y. Top Y. Hey, what do you think about the background noise that I added? Like you can hear some water sound, thunder, waves. Does it annoy you? Or should I just stick to the regular music? Oh, I can't wait to get rid of all that. You can only hear music. Here, now you should hear. I just stopped the music, but the background noise is still there. Maybe I have really good earphones, so maybe that's why I can hear it so well. Oh, right, location. Yeah, wave. So there's a bit of wave thunder. You're probably gonna hear the thunder. I'll put the music back now. Yeah. Right there, there's a thunder. So now I'm getting a proxy. This has to be wrong. Yep, it's wrong. It's not current location. This is completely bad. It's useful, but not right now. I almost made a massive mistake that would have been hard to backtrack and figure out later. So it's from the proxy cost location down to the parent node.proxycost.position. Oh, let's use position, sure. Okay. That looks good to me. And I also need to compute. You turn insert on or why something? It's because I'm using Vim. I have this Vim plugin, which needs to be updated right now, but whatever. Which means that I cannot type anything unless I'm in insert mode. So it's not just insert where it removes stuff, but it's like when the cursor is there I can write. But if not, I can start doing stuff like this. Poop, copy the line. Or I want to copy those two lines. Poop. I can put them there. Poop, copied. So this allows me to move around and do stuff. I want to go to line 100, so I write 100 and I go to line 100. I want to go back, I think that was line 256, go back, poop. I'm back. Oh, it was 246 actually. So it allows me to move in my code because Vim is supposed to be used with no mouse, which is really nice if you're a programmer. So if you're a programmer and you don't know about Vim, look into it. It might actually save you a lot of time. It's really hard to learn, I guess, kind of, but it saves so much time later on. And you get it with like Visual Studio, with Sublime, with Notepad++. They all have a Vim plugin, which modifies the input. Current node position, perfect. And then I can get the cost. So I want the double, simple travel cost equals compute cost from the proxy, proxy cost position, and then current node position. Okay, so I calculate this simple travel cost and this thing, and then from this one I give you the current proxy cost. Whoa. Tab or space? My tabs are made to be spaces. So if I press tab, 1, 2, 3, 4, 1, 2, 3, 4. So it's 4 spaces for one tab. So there's no tab in my whole code. 1, 2, 3, 4, 1, 2, 3, 4. So I press tab and it does the spaces for me, which is something you should always do if you're a programmer. No matter which language you're writing in, you should never use tabs. You should use spaces, and so usually 4 spaces is one tab. And my editor here allows me to remove them as if they were tabs, but they're still spaces. This is really, really important. So yeah, you can notice that the little dots here, they are not tabs. Like if I did have a tab, it would look like this. You see, it puts an arrow. Why? Because tabs suck. They all suck. They suck because it is not consistent with the rest of the characters. So a tab is something that is sometimes a certain width and sometimes it is not. Let's look at this. I put my goal reworking, okay? I put a tab here, hello. 1, 2, 3, 4, tab, hello. So this looks exactly the same, except this here is 1, 2, oh, this one has a tab here and 4 spaces, which you can see. This one has only 1 tab. So 1 tab is equal to 1 tab and how many spaces I put. Like you see, I'm putting spaces. Oh, now it just jumped. Like it's so inconsistent. You have no control over exactly how it looks. It's nice to line things up, I guess, but I mean you can do the same with spaces anyway. But the spaces are consistent, while the tab is not consistent. Like I do a hello, tab, hello, tab, hello. So the tab is nice because I can do hello. So I can put something, space, that, tab, hello. But now it's like you get a lot of different characters mixed together. And this one here is maybe character 21. And right below, this is not character 21. This is something else that we don't know because the tab is like modifying my columns. This is really, really bad side effects of tabs. So you want, like if you're programming, you want a font. Like the font here. Let's zoom in. Okay. It's making characters be the same width no matter what. If it's a parenthesis, it's the same width as my E right there. Capital N, same width as the E. same width as the C too. The space, same width as everything else. But like the size of it is the same, no matter if it's what letter you have, what character it is. It's the same thing. If you have the tab though, it's not the same thing at all. And it sort of messes up with your alignment of everything. So you definitely do not want tabs at all, ever. If you see a tab, you pretty much know that those guys that are using it, they don't know what they're doing. Like they've never put any thought into actually like the thoughts process. Like the philosophy of everything, like how everything lines up is really big. And then eventually you're gonna learn like Python, and Python is actually really strict about the indentation. So if you're using tab, the indentation is like going to be like 2 tabs. If you like, but then you start to put spaces, and your Python compiler, it tells you, like the interpreter, it tells you, oh, you've put some tabs and some spaces, this is bad. Like it tells you you're like a dumb programmer if you're using tabs and spaces. Like Python is that good. But yeah, don't use tabs, please. I was zoomed out here, but I'm tempted to just zoom in here for the stream. I mean, you think tabs are good until you actually run into annoying situations, and then you start to reevaluate your whole life when you do. Not even in Python, this is like nasty. What? That's why tabs, for those wondering. No, that's not why you want tabs at all. That's why you don't want tabs. I mean, Python is nice. It allows you to choose tabs if you want. But like there comes a situations where you're copying code from the internet. And then you like some people use tabs, some people use spaces. It's kind of, you want to stay consistent. So okay, if you're going to use tabs, at least stay consistent and never mix it up with spaces. If you use spaces, never mix it up with tabs. But I guess use whatever one you want. I guess it's fine, whatever. But we all know that 1 tab is 4 spaces, or 2 spaces. Sometimes people don't like indentation. Whoops. Okay, now I have this travel thing. Let's go fix that. So I'm telling you that I have those 2 spacers. Current proxy cost. And then I want to also give you the travel cost and the cost to the destination, which I didn't compute yet. Good song. Double. Oh, it's end. Thanks for ending this conversation. If there's one thing you need to know about programmers, is that they have a lot of political choices. Some people say tabs, some people say spaces. Everyone is right. But I'm more right than you are, because you're dumb and I'm smart. You see? That's what programmers do. They tell you what you should or should not do. But at the end of the day, you're you and you choose what you like. And even though the other programmer is gonna tell you you're the dumbest person, you have to stick to your choices. Because I'm politically right. And you're wrong. But you're gonna say the same thing about me. So some languages like Python, they say okay, use spaces, use tabs, but stick to only one. Some languages like C#, they don't care what you're using. You can mix them up, whatever, and they're gonna allow you. So like Python, they're trying to force their ideas of no mixing on people. C#, they're not forcing you. Like right now I'm doing my own Appus Pathfinder, which is my own algorithm to do that. Some people are gonna tell you, oh, why did you not use A* and do a bunch of optimization, whatever, you don't need to create your own thing, you're dumb. And then I'm gonna tell you, why do you use A*? My thing is better, and then everyone is right. Sorry, losing my voice. Like everyone has their own ideas about how to implement stuff. Everyone is right, and there's a million ways to do it. Okay, no more errors. What does this mean? It means we're in business. So, I'm almost ready to simplify my node bundle. Oh, did I close it? Oops. I like you enough that I shouldn't close you. Let's close that. Project planning, let's close that. How do I go? Oh, right, there's this little bar on the bottom that I cannot see, but whatever. Path area, close that. Okay. Yeah, I really can't wait to remove all of that thing here. But first I need to make sure my new code works better. Okay, how do I do this? So I'm giving you this proxy cost, simple cost, and I want also a public double full cost. And full cost equals proxy cost dot travel cost plus simple travel cost plus cost to destination, and that's it. So those three things together, they tell me that my node costs a certain amount. So I'm giving you the X, the Y, and everything else is useless. Let's start with that. This is crazy how laggy it is. I'm like holding the backspace thing, and when I leave, I let go, it's still trying to erase. Perfect. So I'm gonna give you the proxy cost plus proxy cost proxy cost should be able to tell me what it is by itself, right? Public override string to string. Oops, not that. So a proxy cost X oh wow, I thought this would get removed. All that oh, the good weather is coming out. Nice. My camera is so high. I don't know if I want to make it that low, but right there, it delayed. So annoying. Rip. Logging to text file? No. Because this would not be real time. If I were to do that, it would be like impure. So that guy says, you suck. Oh, it did manage to do a bit of work. Oh wait, why is there a new line here? That's bad. Okay, I like what I see. This should not be written. Okay, so why am I crashing? Suck. I'm actually making the crash myself, by the way. This error code is me that wrote it. Somewhere in there. Or in there. So it's crashing in here. Get corner location.
I am a robot.
Thanks for the follow, Gabriel 12R. Welcome to the stream. Okay. Why does it not get written? Violates. This should be written. This should be in my debugging somewhere, like right before the crash. 323, you crash. Yeah. Oh, it does write it. A violates. Oh. I just didn't notice that I put it at the... Okay. Okay, so I'm saying that this guy... Oh, I didn't want to put the T actually. Man, I probably shouldn't make my code crash anymore. So 5-3 violates 3-2. Let's not crash. Oh, it still does crash. X crashes. Okay, so I'm finding a new node bundle. Found new node. I'm at 2-1. And I find 1-1 and 3-1. Sure enough, proxy cost. And the location is here. Which is somewhere inside of 2 and inside of 1. Okay, this is good. Boom. I make my new current node. 3-1. Perfect. Because 3-1 is obviously closer to the destination. That's why I picked it. And I say... And I find something called 3-2. I also notice that 3-2 violates 2-1, which is true. 3-2 violates 2-1. So I add 3-2 as a new node. And it's going through the corner 3-2, which is right there. That's perfect. With a travel cost of whatever. Where's the full cost? Am I really not printing the full cost? Let's restart that. I need the full cost if I want to be... Why is this not working? This is a glitch. It's I have word wrap on, but it's not word wrapping. It's the first time I see an IDE that cannot word wrap correctly. That sucks. It's just so bad that you can't even word wrap correctly. And without stuff going off the screen. Can I put a space without having it crash on me? Nice. Okay, you win. Fine, new line there. Travel, perfect, perfect. Okay. Word wrap is not working. Let's do that, whatever. Okay, so I start at, as earlier, at 2-2, I find 1-1, I find 1-3, I use 1-3, and I discovered that 2-1, 3-1, I discovered 2-1 violates 3, I noticed that 3-2 violates 2-1. So I create a new proxy cost which has the location 3-2. Really good. Keep going. So that's the only thing it found. 3-2. Next. So I make my current node 3-2, and I discover 3-3. Found a new node 3-3, which has the same parent, like the same proxy cost as 3-2, which is true. Really good. Full cost. This one has a full cost of that. This one has a full cost of 6.6. Is that true? Is that right? Is that accurate? How does it only gain a single point? Like 0.1? Is it really that good? No, it can't be. Is that 3-2 and the travel thing? So that plus that. Oh right, okay, so the full cost is not that much because the destination cost is now lower. So while 2-1 had a very 3-2 had a very low high destination cost, this new 3-3 has a pretty low, so it sort of almost makes up for it. Okay, so that's fine. How is it going? Pretty good, Dedile. Welcome back, by the way. I mean, my back is starting to hurt because I've been sitting here so long. Okay, in the new current node, I'm at 3-3. I discover, hopefully, 4-3. Sure enough, I discovered that. And 4-3 now has a 4-3, very good. So all of this works. And I also discover 3-4, right? 3-4, which 3-4 violates 2-1. Nice, that's true. Also, my whole brain is about to explode, but yeah, whatever. Current node, now I'm at 4-3. Keep going. I discover 5-3, which is true, and it violates 3-2, which is true. But it crashes. Five, 3 crashes. Right. Right, I forgot about that. Okay, I know why it crashes. Okay, I know how to fix it. Mhm. So instead of using this, we can just use B location. Dot pass dot x. I believe this is gonna fix my bug. B location dot x. Hello, Relaxo Man. No time for sleep? No. A location equals a node dot get center. Okay. I guess I forgot my pass. Remove all of that. Okay, next. Okay. Da 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 da. Relocation dot pass dot y. Whoa. Hey, thanks for the follow, Guto Break 1503. Welcome to the stream. Oh, okay, no, this is fine. Okay, I just got confused for a sec. Whoa, I hate how it jumps. Wow, you motherfuckers. Let's just make it crash again. How does this look like? Wrong. I could have sworn I fixed that mistake yesterday. Hmm, 5-3. I mean, whatever. My code is better already for this change, probably. Can't wait to go outside and walk. Okay. Right. Yeah. So, I know exactly why it's not working. It's kind of annoying. Okay, fine. Right here. Instead of giving A, I think I need to give it C. I think that's what I need to do. Actually, let's crash it. And abort. Okay, good. Let's put the crashing code back. Now it doesn't crash. Okay, let's get that pathfinder path solution thing, and let's and let's have a public. I want to draw all those lines that I'm going through. How do I draw those lines? What do I do to do that? Okay, I'm right here. So I'm going through that path memory count. I'm backtracking. Node bundle. So as I'm backtracking, I want to also have list of node bundle with equal new list node bundles. Okay. Okay, now perfect. Node bundles. Backtrack is at null. So you're gonna add bundles that add backtrack. Okay, this is gonna be the most interesting one to see at this point. Node bundle, final bundle. Oh yeah, this is gonna be nice. List. Final bundles, perfect, and then otherwise just create a new one. Final bundles equal new. Hello, Uzi Kudi. Welcome to the stream. You're just on time to see Epicness very soon. What kind of game? Okay, I'll explain. It's a top-down 2D game. So you're looking down at the floor, where your goal is to go from one platform all the way to the next one. Okay, and you do that by going through a level. So that's the basic idea. Obstacles are a level consists of cyclical time-based obstacles. So so there's gonna be some explosions on tiles. So at 1 second, maybe this whole half is exploded. Second 2, this whole half is exploded. Second 3, maybe the whole top here exploding. Maybe after that it's this one that's exploding. So your goal is to look at the pattern while you're sitting there to notice where to be and when. So in some cases, for example, you're gonna want to run all the way to this corner. Perhaps you go back here. Then maybe you wait like 1 second, and then you go all the way to the corner. Maybe wait half a second, go back here. And once you're done, you're here, you wait maybe half a second again, and then run all the way to the end. This could be, for example, level number 1. Probably too hard for level number 1, but whatever. Maybe, so once you reach here, you're done. You're ready for the next one, where you're again trying to get to the next platform. So for this one, perhaps you're running here, go down, go back here, perhaps go here, then go back here, go back up, and then end. Maybe that's what this level is, so it would look something like this. So it's gonna feel a bit like a dance as you're going through those, because you need the right timings to walk through that. So this is the core idea, the core mechanic. So there's gonna be a story to this, so some sort of campaign where there's a reason why you're trying to get through those levels. And also, yeah, I think it's gonna be fun. And so that's the basic single player mode. I want to make also a multiplayer mode where everyone starts at the start, and then if it's co-op, the first person that beats the level unlocks it for everyone. And then everyone can, so one guy gets here, and then everyone can cross over and then play on the next one and try to beat it. So it could be a co-op mode where everyone tries to beat the whole thing together. It could also be a competition mode where everyone again tries to co-op together, and then the first one that beats it gets a point. So yeah, you could try to speedrun everything. This is true. So the first one that could get through this could get a point, but it still unlocks for everyone. And also you could have a multiplayer competition mode where everyone is on their own, and it's a race for who can reach the finish first. That could also be a possible idea. And then also, so there's the campaign, which I will be hand making the levels. So there's gonna be some sort of story. I don't know if it's gonna be a big story, or if it's gonna be just a small one with abstract ideas, philosophical styles and everything. But there's also gonna be an endless mode where the computer auto-generates levels and you try to beat as many as you want. I'm not sure if I can make that fun, but if it's fun, then I'm gonna add it in the game. Hey, hello Gunnar. So yeah, that's the basic idea. So essentially your screen is gonna try to follow you through those puzzles. So it's gonna be as big as possible, and then you can sort of play through this and then reach the end, and then once you're at the end, poop, shift, boom, next puzzle. Next arena or whatever, next level. If the game is too hard, I'll probably be thinking about writing an AI that's gonna show you how to go through the levels. Cause there's two phases. The first phase is you sitting here and looking at the explosions or whatever it is. You try to find a pattern where you can walk and always be alive. Cause if you just run through this, you're likely to die. Actually, if you don't die, it's pretty bad because the level would be runnable. But like if the level is too hard and you can't figure it out, it could be nice. Maybe if there's an AI sitting there and you say, show me. So this would be like a cheating mode. And then you see the AI go through this and then unstuck you. But maybe this is not required because probably the internet is gonna post all the solutions to everything. Obviously, I guess the internet cannot post solutions to auto-generated levels. So maybe it's nice to have an AI later that can show you how to beat the puzzles. I do not know how to do pathfinding algorithm. Well, that sucks. Sucks to be you. Because my algorithm for pathfinding is awesome. Oops. Did I do that? Where's the mistake? Final bundles, really? Oh, right. Whoops. I just added an argument. Let's go fix that right now. Final bundles. Because look at this lovely algorithm. It's almost finished, but this works in real space. So it's always gonna find the shortest path. Look at that. Boom. Shortest path. Boom. Shortest path. Boom. Boom. See that? This is as lovely as it gets. Boom. So it's a bit like League of Legends, where you right click and it brings you there, going around the obstacles. In this case, going around the blue squares. You see, it's real space, so it's really nice. Void. Draw. Proxy cost. Draw proxies. Okay, so for each bundle, node bundle, n in bundle list, what do I do? I compute the location. So location 0.1 equals n dot node dot get center. Boom. Location p2 equals n dot proxy cost dot location dot position. Oh no, that's not a function. Very good, and then I do my draw line. Draw a line, please. Perfect. Where I give you the S and the pixel. P1 dot position. P2 dot position. Some color, which could be color dot black. And then the size dot width divided by 32 in this case. Okay. Mm-hmm. Da, 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 da. Okay, there's no hotkey for now. Let's just draw this. Proxies. S. Final path. Full path. Dot. Final bundles. And then the global offset. Sprite batch. So what programs are you using to make the game? To code, I'm using Visual Studio Code. To go on internet, I'm using Opera. To draw, I'm using MyPaint. So my whole planning of this game is drawn using MyPaint. To stream, I'm using OBS. To make my art, I'm gonna be using GIMP and Blender, and that's pretty much it. To make my music, I'm not completely sure yet. I might be using LilyPound to write the scores, I'm not sure yet. Maybe Audacity. We'll see. So everything I'm using is open source. Is this not getting drawn? Or is this 32 too small? Draw proxies. Okay, fine, I'll do one. Oh. Oops. I think. Yeah, oops. Add. Final bundles, add. Path solution. I'm giving you that final bundle. So why is this not working? Drawing. Cool. The bound. Is this a MOBA? No, it's not a MOBA. Drawing cool. Why are you not drawing anything? Oh, I forgot. Yes. Right. I knew that. Is this a MOBA? Processed. One. Processed. Location 1. Let's use a nice name like this. Equals new location. P1 dot pass dot x times okay, let's actually forget about that. Boom, let's cheat. P1. So minus 1 is P1, sure. P1. And this is 0.2. I'm gonna explain the game very soon, sorry. By the way, hello, James E.D. Smith. Ed Smith. Sorry, I'm not responding too much just yet. I'm coding. And it's so close. Processed 1. Processed 2. How does this look like? This has to work. Boom! Oh! It's wrong though. Isn't it? Yeah. They're definitely lying. Why are they lying? That's not right. When your own code is lying to you. Weird. I could make this like 3 pixels maybe. Just so you guys can see better. Or 5 pixels. Too much. I should record myself explaining the game and putting that on YouTube. And then every time someone asks, then I don't need to re-explain. I just play the video, for example. The Bound Hound. Right now it's just a temporary object that looks like a circle, but it's gonna be the player's look. So yeah, I'm gonna explain to you. Let's go back here. So this is what game this is. It's a top-down game where the controls are right-clicking. So you're somewhere, you right-click, the game brings you there. or you write your so yeah, and it goes around the obstacles. So if you click somewhere like here, it's gonna go there and turn for you, just like in StarCraft or League of Legends. Yeah. So the game is a game where you start on a platform, like this whole platform thing, and your goal is to go to the next platform. You do that by going through a level. The level is made with time-based obstacles. Okay, so at specific times there could be, for example, explosions going off. So your goal is to look at the explosions and figure out the way to cross this without dying. So obviously if you just run, you die. I mean, you're likely to die. So your goal is to observe the pattern and then say, okay, at this time I need to be there. Then go back here perhaps, then go back here, perhaps go down, go back here, and then perhaps go to the end. So your goal is to figure out where to be when. Where to be when. Then once you reach there, you can say you beat the level, and then you're ready for the next one. So you can't just, even though the levels are sometimes linear, doesn't mean you can just walk straight line. You need to like go back, go in different ways, and then you can beat it. So hopefully that makes sense to you. Oh, you're making a game, Los Colmillos. Ooh. That's nice. Oh, that actually looks good. Wow. Did you make the art yourself? So he has cats? Wow, there's something that looks really natural with the movement. That's actually really good. Pyoko Samurai. That looks like a really good. It's meant to be wolves. Okay. Maybe if I know that they're wolves. It's kind of hard to see if there are wolves. Well, whatever they are, they look really good. I don't know why they look good though. Maybe it's just the movement. It looks. How do you make that? Do you just do like? Do you edit them like frame by frame, manually, or are they 3D objects that you render smaller? So my code is not lying. What just happened there? Oh. What? My code is lying. I mean, it's now not lying anymore. I mean, it's not a lie, but it's using wrong values. Add to list this thing right here. Hello, COD JKL. Welcome back. Proxy. Is that the reason? C? Whoops. Okay, and then I give it C.node. Whoops. Whoa, rip. Hey, why am I looking at that? Okay, I'm supposed to be here. Okay, this is obviously wrong. Okay, this is gonna crash still, but I'm fine with that. Boom, crash, perfect. Okay. How do I get rid of that crash? It's kind of hard. Well, it's not hard, okay, whatever. Oh, that's cool. Sorry, Luler. I can't be more helpful. Oh yeah. It's really broken. Vive le Québec! Hello, Meeper. How are you? How do you learn JavaScript? By just playing with it. So you start to look at JavaScript code, how it is, the syntax, then you look at projects and examples, I guess. It's a lot of research. So first time here, played Overwatch for a few hours. Now I'm learning some Java. Oh, I don't play Overwatch, but I play League, which is better, by the way. Coding game. Never heard of it. Sorry, I'm not more enthusiastic. I've been here for like 8 hours already, and I'm trying to get this to work. Yeah. I'm currently making a game where I'm required to use pathfinding, and there's currently a bug. When I'm watching, I usually have more energy than I'm gonna demonstrate today. So right now my code does that. It finds the path. I made it crash on purpose. You suck. Error. Okay. Crash. Okay. 5-3. So from 3-2, there's an error. So essentially, the error would occur in this case, for example. So I need to generate a new obstacle. Yeah. Okay. Sorry guys, I know what I'm talking about, you guys don't. What I need to do is compute the path. I need to merge. What do I need to do exactly? I need to get this is violating, like every time I go down, a node, I need to compute new things. So as I'm going down, I have this path bound that I keep passing around. Path bound. How do I call that? What's the variable name? Normally I would end the stream in 10 minutes, but I don't think I want to end it until I'm done with that. So that tomorrow I can start on the new stuff. Path bound. Boundaries, sure. Child boundaries.
A robot.
Thanks for the follow, Meeper. Mepper. What do you think when I code you a new website for the bots? I'm not sure. Okay. I need to go deeper. That's a fact. So this is recursive. And I need to pass you something, which is like the child boundaries. But I need to restrict.
I am a robot.
Thanks for the follow, Luler. Okay, so the path bound, whoops. Path bound. C#. Have fun, Lular. Thanks for stopping by the way. Most right point. Hey, this works on any values, right? Int? That's an int. Okay. Most right. Max. Child boundaries that and X. At the game at which you are coding, when it's ready, do you want to sell it? Make it free to play. The game that I'm making right now, I'm planning on selling it on Steam. If I can get on Steam in the first place, but if I can, I'll try to sell it on there. Max. So it's a commercial game. I'm not sure if it will sell or whatever, but if it does, then that's gonna be nice. Most right point, highest, lowest. Wrong, I actually inverted everything. I want the max of that, the min of that, max, min. You think an alpha or beta? I'm not sure yet about that. I didn't really think that far. If I'll make an alpha or... like, I'm not planning to sell the game before it's finished. Maybe I'll get some people to test it, but I'm not sure yet. Or I may just test it myself for a long time first. Okay, so this is kind of wrong right now. So this should be B, I believe. B.node. B.node. Whoops. Yeah, it's gonna be, that game is like taking forever. A node. Okay, I want that. So everywhere that it says a boundaries, I get a bound. Perfect. A node boundaries. A bound. Whoops. Ah, shit. Okay, good. Return, get corner, location, boom. A node dot bounds, node boundaries. So this should not break anything. So I give you A and the child boundaries. Okay, this is not right, but it's interesting. That's pretty funny. Actually, what is going on? All these guys are good, but now this guy is not good. Like, this guy is good, this one is not. Huh. Let's go up all the way down there. Let's go there. Could it be that I inverted my thing? This. Ah. Okay, what is good? What is going on? I start at 2-1. I discover 1-1. And I discover 3-1. Okay, so now I make 3-1 my current node. I discover 3-2, which violates 2-1. That is true. How does it end up being 3-4? So the boundaries are just bad. Why? Something gets inverted vertically. It's probably here somewhere. The most right point.
You are the best.
Why? Like, I don't think this would make a good... I don't think that would be right. Max, let's invert it, but I think it's gonna crash. Max. Oh, I found it, I think. I think I'm giving my values in the wrong order. Okay. Yeah. I think that's what is happening. Just crashed, that was crazy. Whew. Always scares me every time. Yay! How amazing is that looking now? This is so nice. There's a random one there though, for whatever reason. Really like that sound. I can't seem to break it now. Oh, right there. that guy wants to go through there. Why? 5-3. Why is this guy out? Can I reproduce it again? Yeah. So this guy, which is 5-3, thinks it should be at 6-2. Oh. That's because I'm using not the shortest path. Oh, nice. So the old cast found a bad path. Huh. Okay, now that I know that my solution works, it's time to remove everything that is useless. Oops, I just went too far down. Add to list. Okay, first of all, just to make sure everything really breaks, let's remove all of that. Cost parent cost remove. Cost remove. I-bottom cost remove, 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 remove. Oh, not that though, please. Okay. Useless, you're useless. Okay, so now this one, you get a new parent, you also need a new proxy cost, I proxy, a double I simple travel, and a double I cost to destination. Like that. So this is good. Is cost important? Useless, useless, useless. Best parent node need to compute. All of this is useless. Get node and open. Get rid of all that. If new best cost, full cost. Okay. Node and open, get rid of all that. Oh, this is so satisfying. Getting rid of all bad code. Is there anything in this world more interesting? No. Oh, I'm just kidding. There's plenty of stuff, probably. Okay. I need a new node best, old node best. Got full cost, perfect. But if the new cost, what is the new cost? Double new full cost equals Whoops. Okay, this goes below here. Hello, Katsu. Current proxy cost dot travel cost plus simple travel cost plus cost to destination. Boom. Okay. So if this new full cost is truly better, new full cost is smaller than that, then we have a winner. In other words, oops, not that, that. In other words, I want the proxy cost, the simple cost, and the cost to destination. Pathfinder equals current proxy cost, simple travel cost, and the cost to destination. Perfect. How are you doing, Katsu? Get best corner cost, delete. This, get best parent cost, delete. Good, I was sleepy. I'm gonna be pretty sleepy after the stream, I can tell you that much. Get best node. Okay. So the current best node is equal to that. Best node dot full cost and ilist dot full cost. You dueled with Tasty and you lost all the games. Hey, full damage Kled is pretty good, I think. Isn't it? But one of those days you just can't win. Yeah, remove that. Is cost important? No, it is not. This is so good. Get rid of top corner. We don't care anymore. Get rid of that. Don't care. Don't care. Don't care. Don't care. Don't care. Don't care. Rid. Delete. 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 Everything goes down the trash. The trash can, trash can, trash can. Oh yeah. Get best parent. Somehow this is still used somewhere. It's only used by itself. I'm gonna get rid of that at some point. We didn't have enough utility to win. Oh. Parent cost. So path locations is now useless. Let's get rid of that. Path solution. if backtrack.parent equals null, remove. You can add the start location right then and there. What is the mistake here? This, yeah. Get rid of all of that. Okay, and then the cost itself I need to remove. Cost. Cost node. Delete. Yeah. You get some coat or something? No. I just drank water. Let's see. Very good water. This keeps me going for days. Boom. It's working. Oh, it's working. Wow, this is worth 3 days. But now I have the best algorithm in the world for pathfinding. Water, Swift Rage. Why is this Swift Rage not loading for me? Hey, it didn't load on stream too. What? Swift Rage is not working? What's working? The pathfinding algorithm. One sec. I can't. I don't remember. Oh. Wait. Show cost line. What is that? Where do I get this from? Show. Wait, what is that supposed to do? I'm lost. Proxy. It's J. Give me a second. What? Did I just put the wrong keybind? Show proxy line, draw nodes. Oh, fuck me, right? Maybe it's fine to keep them together, whatever. What's working? Oh, by the way, welcome to the stream, Alpaca Damage. Oh, this is hidden by default. So as you can see, I click somewhere, right click, and my guide goes there. And he's taking the shortest path. And all those little lines, They are all very important. Oh, this is crazy good. So this is pathfinding in real space, so it means I can click anywhere and it goes there if it's not over an obstacle. See that? Don't mind those squares. Those squares are just there for showing where I start from and where I am. So you see, no matter where I click, my guy goes there. And he goes around the obstacles. See that? Oh, yes. It is very nice meme. Whatever, for now this is useless. What if it's unreachable? Well, let's find out. What happens if it's unreachable? I actually don't know myself. No, just kidding, I know, but let's try it. Alright, it's my content map data. So if I cannot go from my A to B like this. So if this is the map, what's the stream title? It's Creative Game Dev Day 12. So I can go in here, but it cannot find a path if I go there. So it doesn't crash or anything, it just can't go. Huh. Maybe it shouldn't stop though. To the closest possible spot? I don't know, maybe that would be a good idea, or maybe not. Though the fact that it stops is probably something that I don't want to do. Okay, so I think with this I'm done with this stream. Tomorrow there's one more thing I need to work on concerning the pathing. It's this, where when the angle that I'm going to could be just not there. Like I'm going to the corner there, but it shouldn't go to the corner there. Oh, the game, sorry. The game is called The Bound. It's written right up there, but you probably can't read it on your phone. Oh, that guy already inserted. I might tomorrow change the title so that The Bound, the name itself, is closer to the front of the message. Maybe it's better. I thought about this yesterday, but I didn't do it. So yeah, this was a really massive day for progress. I managed to rewrite a whole system once again. The travel cost computation. Okay, so let's put a note so that tomorrow I remember that. Oh, this also could be simplified. To do this whole code is now be simplified. Yeah, the progress is really nice. Well, I mean, I did spend a lot of time. What? The indentation is wrong. It's only 3 space instead of 4. Whoops. And thanks for lurking, by the way. Okay. No idea why this code was doing that, but whatever. Okay, so this whole code could be simplified. Yeah, whoops. You don't need to. Yeah, this is just good. And backtrack, yeah. Okay, so right here. Dun, 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 dun. Dun, 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 dun. Wow, this is the perfect song to play right now. Les heures, the hours. Dun, 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 dun. It's not there. So, yeah, so with that I'm gonna end the stream. I just want to do one more thing. There's one more thing I need to do. I mean, I'm not doing it today, but I need to put a note at least. To do check for the angle. Okay, this is the note that is very important. So I am not violating the bounds restriction if the angle from, like, if this is the angle, let's remove that. So if I start here, I want to go there. Oh no, that's bad. And I want to go like there. The angle is gonna be like this. Obviously you can just go straight. Let's try it. Like right there, you see? You don't need to go through this corner. You can just go straight to your destination. So this is, you know that this is true because of the angle. I actually want to test something. Maybe this is gonna break it. Maybe my code that I'm thinking already is bad. Let's say this is the case. Maybe I cannot always simplify it with the angle. It's hard to say. Yeah, I cannot always simplify it with the angle. Hey, this guy here is making a mistake, or isn't he? Well, I guess the path is just like pretty much the same length, like close enough. Thinking. Maybe it doesn't matter, because by not having a node here, then the one that I'm breaking is this one. Yeah. I think this is fine. So I think removing based on the angle is fine, because then it's gonna snap it out and then it's gonna look deeper, and then it's gonna find this corner instead, which this one is not gonna be too big of an angle. Yeah, I think my system is gonna work anyway, even with a scenario like this. Yeah. So if it's not too big of an angle for both of those corners, then it's going to go straight down. Wow. What will be? You don't know? You've been here every day. You never asked. Okay. I'm gonna explain it right before I quit. You're probably gonna like this game actually. It's the game you're gonna be able to play in League Q, just because of the way it works. Okay. Concentrate. I need to give the best explanation ever. Oops. Oh, I had some coffee left that I never finished. Oh, I'm starving also. Whatever. Since it's Katsu, let's just explain it. So this is a top-down game. A top-down 2D game where your goal is to go from one platform all the way into the next one. You do that by crossing this puzzle. The puzzles are gonna be time-based, so at certain times there's gonna be some bombs that are gonna explode. And they're gonna repeat. So for example, maybe every 7 seconds there's a bomb that explodes here. Maybe every 7 seconds there's a bomb, like anyway. There's gonna be some bomb timings, okay? Or it doesn't need to be bombs, but there's gonna be an obstacle, which means that you can't walk on a tile. Okay, at a certain time. So your goal is to figure out where to be and when. So because of the obstacles, you're not gonna be able to just run it, because you're gonna be dead if you do that. So your goal is to sit here, look at the pattern, which is gonna repeat. For example, if maybe a level is gonna repeat every 7 seconds. So look at the level, analyze it, and try to figure out where to be, like where is it safe to be at any given time. Based on that, then you can start to say, okay, to cross this, I need to walk all the way here. Then I need to go back perhaps. Then maybe I need to walk all the way here, because it's safe there for a certain time. Maybe walk back here, and then wait 2 seconds maybe, and then run. Maybe that's the solution for the first puzzle. So it's not just linear. You need to actually analyze it and figure out how to be safe while you go through it. Likewise for this one, perhaps you need to run here, go down, go back, and then from here, go down, perhaps go back up and then run. Maybe that's the puzzle. Maybe for this one you need to go here, wait a second. Go here, wait a second. Go here, wait. Go here, wait. Go here, wait. Go here, wait, and then just run. And then for this one, you're gonna have beaten it. So maybe this pattern is very easy to figure out. Maybe this one was super hard. So some patterns are gonna be really hard, some are gonna be easy. I'm gonna have to see how difficult I want the game to be. So I want also there to be a single player campaign, or maybe multiplayer, like there's nothing that stops it from working like that, where there's gonna be a story as you progress through the game. I also want a multiplayer game where everyone sits at the start, and then as soon as one person beats it, everyone else can also go there. So one person beats the level, and then everyone can go and proceed to level 2 until one person beats level 2, and then everyone else together can do this. So this would be a sort of co-op mode where there could be any amount of players playing. There could also be a competition mode where it's a race, so everyone is fighting to be able to finish the whole map before everyone else. That could be an idea. Or maybe it's just like co-op with a mix of competition, where the first person that crosses it gets the point. Yeah, racing I think is pretty cool. But it could also be a race of who can finish each level first, and then you get a point every time you beat a level before everyone else. So that could be the idea. So once the level is beaten, everyone else can proceed, but no one else got the point for beating it. So that can be an idea too. And if you want maybe to have difficulty levels, I could put lives where you can only die so many times before it's over. So maybe 50 lives to beat the campaign. Maybe that could be the thing. And then the screen is gonna try to maximize the level as big as possible. What about the man who sets trap during the level? Maybe I'm gonna make a map maker where you get to design your own maps, your own level designs, and then you get other people to play them. That could be an idea. I'm not sure. We'll see. But the core mechanic is that. So with this mechanic, I can do a lot of things. So yeah, thanks for watching. Everyone. It was nice, and see you tomorrow. I'm happy about the progress. Yeah, this thing looks so good now. I mean, it looks better for me because I just know everything that's involved in order for this to work the way it does. But yeah, peace. Whatever you are doing. Hopefully whatever I'm like the angle thing tomorrow is gonna be fast, but we never know. Anyway, have a good day.